Tara. What's that? Start talking. Are we live? Is this thing on? That's awesome. This is going to be... It was worth the wait, I'm telling you. That when we finally get this rolling, it's going to be a fabulous show. Tom outdid himself, I think, again this year compared to last year. Can you actually hear me, Tom? Or are you? I mean, just talking to me. Yeah, he can't even hear me yet. We're getting this set up, but we'll be on course here soon. There we go. That's right. Alan Bernstein's on. Look at that.
We are live now. So I don't know what happened, guys. We lost our link, but our technical expertise was so fantastic that we just recovered in a way that was phenomenal.
That's what you do, right?
That's what we do. So we're live on Facebook, LinkedIn, and YouTube. We are back. I see Alan Bernstein was on. And all that jazz. So
here we go.
Here we go. We're gonna do a restart, regroup. I've got Mark Elliott with me, and he is a sport.
It's a pleasure. It's I've been dreaming about this moment again to spend some time with you, Tom. I jest, but the fact is that the conversations we have at this kind of show, at the Electrical Safety Workshop, you just don't have otherwise, right? There's moments you can create that dialogue with your peers, with customers, even focused safety meetings. But the diversity of the crowd here, the intelligence that we have, the products you get to see, it's great.
Oh, absolutely.
There's always something to learn.
There's so many, like you say, electrical safety professionals that are doing things that are changing the electrical industry, bringing new solutions, and not just products. There's new methods.
Yeah, absolutely.
To use existing products.
Yes.
Yeah.
And I think we've seen more and more relevant is the training behind that and the human factor of products are one thing.
Absolutely.
Right, but I got to know how to use them, and I have to make sure my people know how those operate, let alone what those safety concerns are. And
absolutely right.
This is a great place to capture some of that.
This is where it all happens,
right? And keep current, right? It amazes me the breadth and knowledge of the papers that are presented here, of how much these people know and can share, and it's good stuff.
And we have a paper we're presenting at this event.
Indeed.
And hopefully we'll have that individual here to talk about his paper. And we've got our training people here. We've got products. We've got new arc-resistant equipment, breaking the barriers of how we traditionally think about arc-resistant equipment by bringing new solutions that doesn't require the venting.
Right.
And to your point earlier, we were talking about health and thermal monitoring.
Yep.
Monitoring the state of the of all of the different overcurrent protected devices and switches.
And to add to which we talked a little bit, but not in great depth, but the environmental readings we can get that are relevant, right? So
yes,
the fact is that as we get smarter about how to monitor safety situations, it's not just volts and amps, right? There's lots of things we see that could be as important that I have dust inside that environment.
Oh, absolutely, yeah.
That we all know can be very combustive.
Right. So, and you could open a door, you can close a door, and then all of a sudden you've created a reaction.
Absolutely.
Right.
Yeah.
So we've got Alan Bernstein. So we had Alan. You saw we had a little false start, but and Steve. Good afternoon. Sounds like audio. So tell me, guys, how does audio sound? Because we're using some SM58s here. We're trying to get better with audio.
Yep.
Trying to get better with video. We screwed up the link, but hey, That's live, right?
There's always something to learn and improve on, no matter what, right?
Yeah, and
It's-
every year we're improving on things.
absolutely, continuous improvement.
Continuous
And
improvement.
I think, but regardless of all the great work that Tara, that you can't see behind the scenes, and many folks that support
Yes.
Tom and putting this together, it's a continuous learning opportunity here. I mean, period, right? That's why we're at a place like this.
Oh, absolutely.
Whether
Yeah.
that's connections to the internet or backdrops, and does my hair look okay?
Yeah,
Right?
your hair looks good. Can everybody see his hair? I want to make sure that the video is good, so
Yeah.
I want to make sure his hair is visible.
Yep.
I love it. Alan says the audio is fine, and so does Steve. So we're good.
Good.
Yeah.
Yeah. So
All right. So 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 let me ask you a question. These are your questions, or these are your questions?
these are mine here.
These are yours.
And this is for us, but we'll have to refer it to, right? Because it's
Yeah.
some talking points to get
Well,
us
here's the
through
thing.
this, right?
We're live, and as everybody out there knows, when we screwed up the link and all this other good stuff is going to go wrong, and we got to keep our minds sharp. So creating some bullet items to make sure we hit everything that we're supposed to hit is a good thing.
Absolutely.
So from you're involved with what we call the process industry.
That's right.
When I say process industry, what is that?
Yeah. So that's when you look at the industrial side of things, right? The manufacturing. These are companies that create products.
Yep.
That process is continuous. An operation has a start and a finish. So if I make steel, I start with iron ore.
Right.
I cook it up, press it, shape it, whatever, and out the back end, I now have you a steel bar or whatever it might be, right? I do
Gotcha.
that with cement. I do that with food. I do that, right? So that's a continuous process. And why that's relevant is because they don't stop. So my job is to work with those customers that are in that continuous process industry space, because there's uniqueness about it's always up and running.
right.
And all industrials, including ourselves, we don't ever want downtime, but
Oh,
your
yeah,
downtime looks different if it's a process that starts and stops. Like when we build switchgear, it's a monument at a time.
Right.
I can take a break back and forth, switch products. I can't do that when the glass bottles are going down the line. They got to keep on going.
Oh yeah,
Right?
yeah.
I don't want to not fill one of those wine bottles
Wait, how about beer?
or beer, heaven
Yeah,
forbid, right?
forbid.
You don't want to get a 6-pack that's got 5 of them full.
That's a 5-pack. Yeah.
That's not a thing as far as I know,
not
right?
a thing that I know of. Yeah,
So,
absolutely right.
That's very relevant to them, because it's not just their process is up and running, but they can't have that downtime, and the electricity doesn't stop running, right? So when we talk about to those folks why it's relevant, that looks different than a commercial building,
Yes.
right? And hospitals have their nuances, right, too. But
Oh, absolutely.
but
Wait, would you say a hospital? You said a hospital? Is that a process industry?
it is not.
Okay.
I say that's relevant, right?
Yeah.
But while it's super important, it looks different than my cement process that can't turn on.
Absolutely. Yeah.
I may or may not have human life in the way, but
Sure.
if I stop the ladle with lots of iron ore in it, and it hardens,
That would be ungood.
oh my gosh. It's not
Absolutely.
only a lot of dollars, but now it's dangerous too.
Absolutely
So
right.
anyway, so we talked to them from the electrical safety standpoint of that. It's
I like
very
it.
relevant to talk about how do I keep the process running, either from electrical safety equipment, how we make sure it stays safe,
Yep.
let alone monitoring it, let alone, oh boy, I need to go fix something.
Yep.
Which now is more and more relevant as NFPA 70B became a requirement, which these folks were doing already, but now we have some more guidelines, parameters.
Yeah.
What does good look like to do that? Right?
Okay, so you're seeing more maintenance focus in the process industry,
Absolutely right.
and probably I would. So here's what I think. To your point, processes can't stop, and when they do stop, it costs a lot of money,
And dangerous.
and it can be very dangerous.
Yes.
So you have both in the same mix. You've got the cost of downtime, which nobody. And I heard somebody say this, that if you don't schedule maintenance, your equipment will schedule it for you.
Yes, that's a great way of saying it.
Yeah.
It's going to happen one way or another.
Yep.
All this stuff eventually fails.
Yeah.
And because it just got old enough, or there's environmental factors,
That's right.
or heaven forbid, bad power leaks into your building from the utility because they had a switching transient or a
Absolutely
lightning
right.
storm or whatever, right?
Yep.
Things will happen.
Things are
It's
going to
just
happen.
a matter of time.
You want to make sure that you create that to happen.
Right,
Now, Steve
right.
is saying the new arc flash mitigation devices that are designed or tailored specifically for selectively coordinated systems or just for any system. So there, he says, their new arc flash mitigation devices are designed or tailored. I guess he's asking the question, or just for any system. So arc flash mitigation and selectivity. So here's one of the solutions out there is the energy reduction maintenance switch. We call it the arc reduction maintenance switch. And the challenge with some of that is when I change a setting in a breaker, the comment would be made, I lose selectivity, and that's a
Correct.
problem.
Right.
Okay. Now, the argument against that I've heard at the table at panel 10 and 13 and a few others is when you're the electrical worker who is engaged with a piece of equipment, selectivity is the last thing you're thinking about, because if you cause a problem, you want an immediate clearing of the issue right when it occurs.
Yes.
As it occurs, because otherwise you're going to have an extended downtime, because if you had that delay, because you're in the middle of the system, now you're going to have a lot more damage in the equipment, and you just don't go down to Walmart and buy a brand new piece of low voltage assembly or a motor control center.
That's right.
It takes, and I'm sure everybody out there knows about time delays,
Certain
right?
lead times,
Lead
right?
times.
It's just where the world is, right?
That's exactly right.
And even you go back to when they were healthier, and we'll get there again at some point. Even
Yep.
then, it's not like it's on the shelf all the time for all this stuff.
That's
right?
exactly
These are
right.
engineered to order solutions that you can have spares, but it's not always the right spare, let alone you got to put
Yep.
it in still, and that takes time. I
Yep.
think part of the conversation on that too is that when I'm the worker in front of it, one, selectivity is not what I'm there for, but I also want that arc to be, just away from me. I want
Yeah.
in this cabinet, right?
You want distance.
I want distance because that's our friend, right?
Oh yeah, distance is your friend.
Right.
Just like it's not
just
your
like with the
friend.
microphone. Well played. Yes. So you have to have that trade-off to some
Yeah.
point, right?
Yeah.
And remember, you're not going to be. The whole point of that being a switch is it's momentary.
Yes.
Right.
Oh yeah, and now so that's the other concern we had, and I always say, you treat it like lockout tagout. Right?
Correct.
And it has
That's a
to be a
great way
part
to
of
think
your
about it.
program. You have to turn it on, lock and tag it, go do your work, and when you're done, go back, take the lock off, and turn it back off again. Because people
Yes.
will say, well, they forget to turn it back off, and they leave it on.
And-
well, yeah, that's
right. That's a maintenance program issue.
That's exactly
We'll
right.
go back again to 70B of like that's one of the reasons why that exists.
Yep.
Right.
And 70E
And
tells you
70E tells you that just the same, right? 70E
Exactly.
just reinforces really what 70E was saying in that case.
exactly.
Right.
Yeah.
Yes, but I would share that is relevant not only to what value we would provide to that end user, electrician, whoever,
Yep.
but also what their training, maintenance, and operation needs to look like. So when they know or don't know that
Yep.
they need to go lock out, tag out, and work on a breaker and adjust that switch,
Yeah.
they better darn well, we can help them look at that, saying, what happens upstream, downstream? Does my process have an interruption because of how I set it up?
Oh,
Right?
absolutely.
Because I can't just willy-nilly choose to do it. That's a bad practice.
Willy-nilly. I like that.
That is not in any
Is that a technical
electrical
term?
maintenance program, as far as I know. I
No.
think that gets redlined every time.
I think it should be a part
Right.
of a formal dictionary.
Yes.
Willy-nilly.
Willy-nilly.
I like it.
But I mean, that's a great talking point to go on and on about of like what a maintenance switch does and its purpose, right? But the point is it's temporary, and I should know what's happening upstream and downstream.
It's all about speed. You want to clear the fault as fast as you can.
Yes.
That's the key.
Yeah. So
I like it. I like it a lot. And I think that it's one of those things where, like you say, once you understand it, once you understand how you implement it, and you have procedures and policies in place, you follow those and you make it happen.
yeah, and also, I mean, we need to probably move on to another topic because that's a good one to
Yeah.
drill into. But I would add to it that what's the alternative?
Oh, yeah.
I'm just
Well,
saying, right?
that's what I'm saying. So you have that longer clearing time, and the goal is when you're working on a piece of equipment, you want to clear the fault as fast as you can. Alan says, where are people being exposed to voltage? That's another good valid point.
All over the place, right?
Yeah. So anything that's so you want to understand the hazards, and when it comes to shock, and I would love to get Terry Becker in
Which
here.
doesn't get enough attention because of arc flash kind of taking over. Shock
Exactly.
is every bit as important,
It's probably more because
and it
more
has a
deaths.
high likelihood.
Oh, absolutely.
Right?
It's a high likelihood, and there's more deaths associated with it. So, and Terry Becker,
We'll have to get him.
He's in. You know Terry, right?
Yeah.
So what Terry says is, shock protection is your best arc flash protection, because if you're avoiding coming in contact with energized parts, there's Eric Stromberg from Los Alamos. If you avoid shock, then your likelihood of having an arc flash event is low as well. So Terry's message is, look, let's worry and focus on shock protection. To Alan's point, being exposed to energized parts and things of that nature.
Right.
Let's take that off the table, and then you'll probably reduce your arc flash incidents as well.
Right, because you will not be exposed. Right. And in case of point, and we'll let the product people talk to it, but on our motor control center here, one of the features is an absence of voltage testing device on the door.
Yes.
Well, why? Well, because the doors open and close for a reason on those things.
Absolutely right.
And especially you go back to the continuous process, I can't always turn everything off to go maintain it.
You're absolutely right.
But I can turn off a bucket at a time in a motor control center.
Yes.
And wouldn't it be nice if I didn't have to stick probes in there
to verify? Yeah. So we have there are different manufacturers who have solutions on the market. We include those on our equipment. We don't make the absence of voltage indicators, but we will put those in our equipment. We don't make the IR windows. We will put those in our equipment. We do make thermal monitoring, okay? But I would argue that a lot of these things are not code required.
That's right.
And they need to be specified by consultants and owners and all of those people.
And that's where it goes back to like some of the talk points we had that this leaks into, is that's part of your maintenance program and strategy. Right?
Absolutely.
Nowhere does it say you have to have an absent voltage testing device.
Correct.
Not required.
Now, you know what we did do? We put a permission in Article 230 to permit the installation of an absence of voltage indicator on the line side of the service disconnecting means. And then in 230.2, we put a requirement that it has to be listed for use on the line side of the service disconnect. So what that
and why is that?
Well, I'm glad you asked that question. So that helps to make sure that when I call the utility and say, hey, Duquesne Light, American Electric Power, I need you to turn off power because I'm going to do this work, I can watch that indicator and it's going to tell me my line side is now de-energized, because I can turn the main off, but I got to wait for that. And you're going to have that utility. Or if I go outside and have them pull the meter or whatever it is, I will know that I don't have voltage. Now, in my opinion, I always verify regardless, right?
Absolutely.
But you're
100%.
And I call it the layers of the onion. You have created more layers of the onion to make sure that you have a very high confidence that when you put your probes on there, there is no energized parts there.
That's right. That's right.
Now, let's talk. I got some, Alan Bernstein's chatting up a storm here. So where are people being exposed? He says, industry, it is at drives and PLCs, I/O racks, inside industrial control panels. So he's finishing his sentence.
Yes. I was going to
have 2 minutes. Oh, okay. So what do you got for me?
Well, I was going to exactly share that too, but maybe we could switch. But
yeah,
inside motor control centers often are drives. And drives have what keypads on them. Are they inside or outside the door? And if they're outside the door,
yep,
I'm in exposed space.
Oh,
potentially,
absolutely right.
So,
absolutely right.
And that's again relevant of the more protection I have to see it, whether it's on the door or remotely through another device, and I can, communicate to something and go, oh, I can see now. At least something else that tells me what am I walking into? Am I
Exactly.
prepared? Do I have the right PP on?
Yes.
Do I need a different tool for whatever reason, right?
Absolutely right.
Way safer.
Way safer. And I wonder, when is AI going to get involved with all of this?
For sure, right? And you look at, from that digital standpoint, that's the intelligence where we see that we're more and more getting into from
Oh,
the
yeah.
electrical industry of like, I can collect thousands of data points from this electrical equipment,
Oh, yeah.
but it does no good if it sits on the device. It's cool,
Yeah.
and I
Yeah.
can walk up to the device, I might be able to get information, but now I got to
Right.
be in front of the device, which
Yeah.
has its cons, right?
Yep.
Or I bring it back to a system that says, let's start to analyze it.
Absolutely.
And we've been doing that for years, us and others.
Yeah.
But as we get smarter and smarter in how to analyze more and more data points, I can now do more and more predictive
Absolutely.
safety testing, maintenance programs,
Yes.
etc.
And they're
right?
data points. It gives you information. If you can have a tool that goes through all of that information, gives you a data point that you
Yep.
can use to make up your mind on a direction.
Right. And now that opens up a new can of worms, because I love that part.
Yeah.
And now the new can of worms is cybersecurity.
Oh,
And that's
yes.
a very natural bridge
Yes.
for us, for the folks here, of it's one thing about the electrons themselves, but how
Yeah.
about the computers and the software running that, and people that want to
And
do ransom.
yeah, and they
Right.
call them bad actors, right?
Bad actors.
You don't want the bad actors thinking they're going to mess
Yeah.
in your sandbox,
Right.
and you're relying on technology for safety.
Right. And one of the things that we had in the notes for me was
Yeah.
to talk about, from those process industry folks, they are heavy into their automation.
Yes.
More and more and more and more, which is great.
Yeah.
But automation needs to talk over networks.
And now it's typically Modbus.
And here we're going with this, right? And now I've got more and more things being communicated.
Yep.
Do I go to the cloud or not? And these end users especially are very concerned about, where's that data go, who has access to it, because the last thing I want to do is that bad guy drills into my system somehow and now shuts down whatever process, and I get a ransom note.
Yeah.
Not to mention somebody may have got hurt,
Oh,
or my
yeah, you're
process
absolutely
stopped,
right.
and I've got a ladle sitting in the sky hardening.
Yep.
I'm like, oh boy. So very relevant. We'll get to it, but there's cybersecurity stuff in our booth and around here. But
Yeah.
to show you what that looks like, of we're getting there, and AI is helping enable to learn that ahead of time, coach it, right?
Absolutely.
Super important part of it, right?
Yeah.
We are fully embracing that, but you got to do it the right way.
Yeah, absolutely.
Yes.
We're getting a hook here. Can we have Lanny? Can we have
Look at
Lanny? Lanny, you have a second?
You
Come
can-
on over. Do you
bet.
mind? Excellent. It'll
All
be
right.
real quick. It'll be real quick. Sorry.
Good.
Lanny
Lanny, come
Floyd,
on in. Yes.
one of my mentors, and
Mr. Floyd,
Oh,
have the
Thank you, Mark.
chair of honor, sir.
thank you, Mark.
We'll talk to you at the end again.
perfect. Thanks, Mark. This is perfect. So, thank you for coming over.
Oh, certainly, Tom.
And I don't know that anybody out there knows who you are. I know who you are very well, as does, I think, everybody in this room knows exactly who Lanny is. So why don't you tell everybody, give us a little bit of you.
Well, I've been involved in electrical safety for over 50 years. I worked for the DuPont company for 45 years, started in 1969, and most of my time with DuPont, I was involved, I had assignments in design, construction, maintenance, operation. But throughout all those assignments, my primary focus was our electrical safety program in our company. And for the last 25 years with DuPont, I chaired our continuous improvement team for electrical safety. And after I retired from DuPont, I was asked by the University of Alabama at Birmingham to join their faculty in a graduate engineering program in advanced safety management. So I've been doing that. So here at the workshop, though, this is my 33rd.
30. Well, you were at the very first one.
Well, I was not only there, but I helped establish it.
Yeah.
We created this as a way to bring the stakeholders together, not to identify what's the best practice is, but to stimulate innovation
Yeah.
and creativity. When I look, it's interesting, as I look around the expo here, I see a lot of products that were initiated through conversations and discussions that occurred here at this
That's
workshop.
right.
Yeah.
A lot of innovation happens here around coffee pots, listening to, and I had one individual as a manufacturer, he said some of his best patents came from listening to conversations in this room.
We may be talking about the same individual, but I've had other conversations with very smart people
Yeah,
who heard what end users were dealing with, went back, engaged their really smart R&D folks, and came out with solutions.
yeah,
Maybe not complete solutions, but an advancement in our ability to reduce exposure to hazards.
absolutely right. So are you, having, how many people were at the first one? I know we're almost up to 600 here now.
We had 35 people at the first one, and I still remember it vividly. Some of the real pioneers in electrical
Yeah.
safety were there. This is before OSHA, before NFPA 70E.
Wow.
They were championing best practices in electrical safety, improvements in technology, safety by design. That was, again, 35 years ago.
Yep.
And the opportunities are even greater today than it was then. So
Yeah. It's amazing how many people are here, and the safety industry is thriving, and the knowledge that's being shared in all of the presentations. If it wasn't for leaders in safety like yourself and the other 34 people that were in that room who had a common goal and common vision, we wouldn't have what we have today, which is a thriving. We're changing, and you said it, and you say it all the time. We're changing a culture.
yeah, I remember there was maybe one magazine that occasionally would have electrical safety articles in it back then. Electrical safety just wasn't a buzzword
Yeah.
back then, and certainly it is today. It's hard to go every month. Several of the professional or trade magazines have multiple articles on electrical safety, advertising innovative technology that didn't exist a few years ago.
Yeah.
So it's been great. Again, the more you learn about it, the more opportunities you see.
Oh, exactly.
Exactly.
Yeah.
That's true with everything.
It's
really.
true with everything. Yeah. And the more, like you say, the more you learn, the more opportunities, and then depending upon your ability to translate that into a solution, whether it doesn't have to be a product, right?
No, it doesn't. It can be how you just how you think about it.
Yeah.
What do we do we have that hazard here in our workplace? What are we doing about it now?
Right.
What can we do differently about it? So it's a again, it boils down to conversation and discussion, and that leads to improvement. Whether it's a product, whether it's a way of thinking about it, whether it's a management process,
Yeah.
whether it's just raising awareness.
Yeah.
Yeah. So,
And there's a lot of people out there that I know can't make it to the ESW, which is why I started doing something like this to show, here's the stuff that we do here. And if there's any way they can get here, because, watching something on YouTube or watching a video of a live event doesn't replace being here, enjoying a cocktail or two, some good food and conversation.
I agree with that. Thinking about those people that are not here.
Yeah.
One thing to think about is if you've got a project, a new project, you're adding on, you're replacing, you don't want to replace in kind with equipment that's 20 years old or 25 years old.
Yep.
Take the time to ask your supplier, whatever it is, whether it's a training supplier or a equipment supplier or a services supplier, what do you have different today that can reduce my risk of exposure to hazardous electrical energy?
Yep.
Every equipment manufacturer that I know offhand has something. And oftentimes, that's not what people are asking for. They would just want to replace in kind, or I want to buy the same switchgear that I had 15 years ago because I don't want to have to train my folks.
Oh, yeah, yeah. Yeah.
But if you do that, you're Don't be stuck in the 20th century.
That's right. That's right. Yeah, that's so true.
Okay.
You've got to advance. You've got to learn new technologies. You've got to understand how to implement those new technologies. And the trade show, I think, is a great piece of
really
the puzzle.
is. It really is.
Yeah. Yeah, we've got a lot of people out there watching and making it happen. We got Alan Bernstein. I don't know if you know Alan.
I know him.
Yeah, he's out. He's watching this. I told Alan he usually goes to PCIC. I said he needs to be here now.
Oh, okay.
He says he's retired, but I'm like, hey, come on over.
Yeah.
We got a lot of friends here.
Well, you can't be everywhere, but that's why what you're doing here today. I know you got other folks lined up to talk.
Yeah.
That's the way to have. I know you do a lot of YouTube work.
We
yourself.
try. We try.
And that's all the tools we can muster to reach out and engage people.
Yes.
Is just an improvement.
And the more they see what's going on here, maybe this will prompt them to go back to their leadership and say, I need to be there. I'm a safety professional. There's a lot of things that go on there, and I need to be there.
You know, that's a good point you just made. It's not just electrical folks here. We got safety professionals.
Yeah.
Today we had a lawyer, and who's an expert in electrical litigation.
Right.
He shared some of his expertise in that. We have, well, I said occupational safety professionals. We've had doctors, physicians.
Yep.
You know, I call them the stakeholders.
Absolutely.
People who are involved in some way, either with preventing, protecting, or treating.
Yes.
Helping injured victims recover and get back to work.
A lot of opportunity.
Yes, it is.
Lanny, I really appreciate it.
Thomas, I really think the opportunity, and I see we got someone else lined up.
Yeah, we got people lined up. You set that down, and I want to shake your hand. Thank you. Thank you very much. What a true leader in electrical safety. Lanny Floyd began this whole adventure years ago, made it happen, and I don't know. It's just great to be a part of an effort like this. Emily.
Hello.
How are you?
Doing good. How are you?
Excellent. I can't complain. Well, I could complain, but I won't.
Okay. Okay. This is a different microphone setup than last time, right?
Yeah. So what we learned was that the first time we did lapels, caught a lot of background music, background sound.
Yeah.
And then we tried the Sennheiser boom mics. Well, that was a big mistake. And
Okay.
now what dawned on me was these microphones are used by singers in rock bands,
Very cool.
and they use these because the cone is right here. So I put this little soft thing on to stop the
Yeah.
the puffers or whatever.
Mhm.
So I think this is going to work, and they said that the sound works good
Good.
and all that good stuff. So why don't you do this? Why don't you let everybody know who you are
Okay.
and what your role is?
So my name is Emily Offenloch. I'm the Associate Product Manager for our medium voltage motor control line. So that's medium voltage variable frequency drives and medium voltage motor starters.
Oh, okay. So medium voltage.
Medium voltage.
That's like that's big stuff.
It is big stuff. Yeah. About
Yeah.
4160 is kind of the prime example.
When you let the smoke out of medium voltage equipment, it goes boom big
It
time.
goes boom big time, and we're talking about big booms today.
That's
with
exactly
our
right.
consistent equipment. Yeah.
Yes, and what your job is to make sure that those booms don't go into the room. Hey, we got a song.
Mhm.
We got the microphones. We got the whole. We can rhyme. But so arc resistant. Why don't we just talk a little bit about what is arc resistant?
Yeah. So, are you familiar with what an arc flash is?
Oh, that's a good question. An arc flash is the rapid expansion of light and heat and sound, and there's sometimes debris in there.
Hmm.
And I said light.
You said light. You said sound.
Did I hit it all?
I think you hit it all. Yeah. Basically, a bomb is going off.
Yeah.
Right.
Yeah.
A bomb is going off inside of your equipment. If you have anyone in the room, that's catastrophic. Your copper inside of your equipment is instantly vaporizing.
Yeah.
It expands to something insane like 67,000 times its volume.
So that means I take like a penny and you expand it 67,000 times, you can take a penny and fill the volume of a refrigerator.
Yeah, and
When
that's just a little
That's
penny.
just one little
Yes.
piece.
Yeah. The temperature inside becomes 4 times the temperature of the surface of the sun.
Now, let me ask you, how do we know that? Did we measure
That's an excellent question. Yes.
it? But we did it at night, so it was safe.
Yes, of course.
Of course.
But yeah, so basically, if you're in front of that equipment,
Yep.
it's bad news bears. Things can be ejected from the equipment, doors can be opened.
Yeah.
Like literally any of the things that you mentioned, like the sound, the light, the heat, is
Exposing everybody in that room to that.
everyone in the room, and every one of those things can permanently damage.
And the other thing, so I don't know if you're familiar with the Nuclear Regulatory Commission is researching what they call HEAF events.
Okay,
HEAF, high energy arc flash.
got it.
And what their concern is that when an arc flash event occurs in one piece of equipment that, say, is non-safety related,
Mhm.
that could propagate to other equipment in the room that could cause maybe a safety related piece of equipment
Okay,
to now feel the ramifications where there was perfectly fine, it was operating fine, but because of the close proximity.
Mhm.
So it's not, and it's not just other people, it could also be other
other
equipment-
essential equipment. Yeah.
essential, I like the way you said that, essential equipment that
Mhm.
that if that goes down could have ramifications. And in a nuclear plant we know what those are, but in other I just had Mark Elliott talking about process. It could be a steel related process
Mhm.
where you might have raw material emptied onto the floor which could hurt people. So
Yeah.
containment is a form of, I would say, it's not avoidance, but it's
It's called passive
oh,
or
I-
passive arc resistance.
okay, I like
Yeah.
that. Passive arc resistance.
Yeah. So active is like you have a piece of equipment that when it sees an arc flash, it's gonna do something to stop the arc flash.
Okay.
Typically like arc quenching,
Right.
arc flash sensors, optical sensors.
Yep.
Passive is you're saying, okay, the arc is happening. What can we do to protect after an arc has happened, during an arc, after an arc has happened, etc.
Right.
Yeah. So arc resistant is about the bomb is going off inside the equipment. How do we prevent, regardless of the length of bomb, type of bomb, whatever? How do we
Yeah.
keep people in the room safe?
That's
That's what arc resistant equipment is.
excellent. All right. So how do you make equipment arc resistant?
So yeah, so there's kind of two parts. One is literally containing the bomb. How do you contain a bomb?
Yeah.
You put a bunch of heavy steel and you bolt it up really tight. You test in your, specifically the standard for arc resistant is IEEE standard C37.20.7.
C37.20.7. Okay.
And that is you specifically, intentionally create an arc in your equipment and you see what happens to the equipment afterwards. So for that one specifically, you're
Yeah.
looking at, do doors open?
Right.
Is shrapnel ejected from the machine, and how much does it weigh? So
Yeah.
that is what that portion of the equipment's looking at, is literally keeping the doors on the equipment.
That's I like you added, and how much does it weigh?
Hmm.
Because you may still have particles ejected from the equipment, but if they're so fine
Hmm.
and they're not of substance.
Yeah.
Interesting.
Yeah,
I
it's
thought about
certain,
that.
I think it's like 20 grams, something like
Is that
that.
what it is?
I think
Okay.
so.
Okay.
It's weighed, and then if it's over that, then that could have you could have flown into someone, so you would fail the test at that point. But if
Right.
it's under, then you would pass. So that's the bolstering of the equipment itself.
Yeah.
And then there's the equipment is contained in the bomb, but there's still a bomb going off. There's a
Right,
fiery
right, yep,
explosion.
yep.
Where do you put that?
Right.
So typically you would have exhaust ducts, kind of like HVAC ducting,
Yeah.
that the bomb would be routed through and shoved out of the building and ejected into a designated safe area
Right.
where the flames can shoot out and it's not over a picnic table or something. It's a designated area
Gotcha.
where if flames shoot out, it's safe.
Right. Okay. So you would like you say, usually take it up and out of the building,
Yes, yeah, usually.
and you've gotten better at that.
Yes, we have a new product that eliminates the need for exhaust ducts.
That's awesome.
It's so awesome. It requires these ceramic absorbers. It's like that big. We have it at the booth today. They're like this big. You
Yeah.
put 12 of them in the plenum, the upper part of your equipment.
Okay.
and your exhaust blast is routed through those ceramic absorbers.
Yeah.
And the absorbers filter the gases, they cool the gases, they reduce the pressure wave that's created by that explosion.
Sure.
And then the cleaned and cooled gases are vented into the room.
So you've
The
built a
electrical room.
muffler.
Essentially, yes. And like I said, the testing for this, they basically simulate if a person was in front of the equipment, would they be okay? So
Right.
they're looking at the shrapnel, they're looking at doors coming off. They set up these cotton indicators all over the
The
equipment.
cotton don't burn. You're okay.
Exactly. So same thing with the arc absorbers and not using exhaust ducts. The gas can vent into the room, and
Yeah.
there's no flammables being emitted from the equipment.
That's pretty awesome. And that would be protecting from internal faults, but all the doors still have to be
Yeah, all the
buttoned up.
doors are buttoned up. Yeah, nothing's going to open. You
right.
could even have the low voltage door open. So on our equipment, there's a medium voltage door, a big door.
Yeah.
There's a small low voltage door.
Right.
You could have the low voltage door open, and you could be working in front of it. And an arc could happen inside the medium voltage portion, and you would still be safe.
I did not know that.
Yeah, that's called type 2B.
It's called type 2 what?
B.
B.
B, yeah.
Type 2B. So are all arc resistant equipment type 2B or
No, you have to be certified to that level.
okay.
Type 2B specifically means that you could be standing in front of the front of the equipment, the side, the rear,
Right.
and you could have a low voltage door open and still be safe. So I think there's a type 2, I believe there's a type 4.
Okay, so there's different types.
There's different variations.
There's
yeah.
different variations now. Would a consulting engineer or an owner have to specify they want type 2B or type 4 or type 1?
Typically, yeah.
Yeah.
We certify only type 2B because we want people in front of the
Thank you.
equipment. Yeah.
Thank you. That was going to be my next question.
Yeah.
Like, okay, how many model numbers? So, okay, so we go after the one that we make sure that if you are working on the low
Yes.
voltage, you can do your work. And if there's a fault in the medium voltage bus or whatnot, that is all contained, still protects the electrical worker. And I bet
Yes.
they run the test with those low voltage doors open.
They do. They do.
How'd I know that? Excellent. Excellent. All right. So now that makes sense. I was sitting there in my mind thinking, oh boy, here we go. How many catalog numbers? And
Yeah, no.
yeah,
Nothing
that's
like
good.
that, yeah.
That's good. Well, see, you guys are smarter than I am. That's good.
And eliminating the exhaust ducts, apart from the safety play,
Yeah.
I mean, like in all aspects of design and planning the
Okay, well,
equipment, it's
You have
so
to
much
have
easier.
you have to have space. If you're downstairs, then you have to have the upstairs have the room for the ductwork.
Yeah.
So you're and everybody knows space is a premium in any structure.
Yep.
So you have contained it into the one space. Oh, here's a question. It's got to add room on top of the equipment.
Actually, it's the same amount of height that would be required on our equipment.
Really?
It needs exhaust ducts. So space
Oh.
requirements
Are the same.
are the same.
Okay, so same footprint, width, height, and all that,
Mhm.
and then you're just exhausting into the room. So I don't have to take it out. I don't have to worry about upstairs. So you're saving room, saving real estate.
If you're in a place where you can't get outside, like if you're in a mine
Yeah.
way underground and you don't have a space
Oh, I
to,
never thought about
exhaust
that.
you,
So
yeah.
now you've opened up more opportunities on
Mhm.
where you can put the equipment.
and if you have non-arc resistant equipment today
Yeah.
and you want to upgrade and say, okay, I want arc resistant now,
No.
you don't need to plan for ducts anymore. You can just put the equipment in.
Don't tell me that. Okay, so you can change the equipment
Yeah.
and not have to. So now you've opened up a lot of. So I'm sure as a what's your role again?
Associate product manager.
Associate product manager. So from a product management perspective, I'm sure you're like, hey, we can sell this thing into more places now. We
Yeah.
can provide more solutions. It opens up markets for you, places where you couldn't put the equipment before,
Exactly.
and it brings value to the end user. I like safety products because it's a win-win-win. You win, the manufacturer wins because you're making money, obviously.
Mhm.
The consultant and the contractor wins because they can bring value to their owners, and the owner wins because and who eventually wins are people who work on equipment
Right.
and have to live with what we've built for the next 25 years.
Yeah.
So it's like seat belts, you know?
Yeah, it is.
It really is. And you don't realize you needed it until you didn't have it.
Right.
Right. So, all right. So now somebody else told me, I don't know if it's you or if it's someone else. Do the medium voltage drives, or is that somebody else?
We do medium voltage drives as well. Yeah.
Is there something you don't, you don't do low voltage? So you do medium voltage drives.
Yeah.
Do we have this technology in drives?
So we have an arc resistant design in drives.
Okay.
You can kind of combine these two products together. So medium voltage drives, everything past the isolation transformer has a lower level of incident energy. So you don't need exhaust ducts for that half of the equipment.
Okay.
On the incoming section, where you do have those high levels, you can put the ductless on that incoming section. So for the drive, you can remove the need for exhaust ducts.
Okay, so they probably make the equipment sectionalized.
It is, yeah.
Okay, all right. So you,
one chunk would have the ductless or your exhaust ducts, and then the other half does not have ducts.
awesome. And you called it a passive
Passive arc resistance. Passive arc mitigation.
passive arc mitigation. I should have known that, but I did not know that term until just
There you
now.
go.
So I learned that. I learned the B, right, which
Type
is
2B.
Type 2B, which I can have the low voltage doors open. We don't have to worry about the vented on the top, so I can fit in the same space, same footprint.
Mhm.
I want 50, 60 years of my infrastructure. I'm just looking at some comments. Believe that this unintended, Robert from Omaha, unintended rapid disassembly. Yeah. Oh, and there's the other thing. A lot of people, so when we show videos of arc flash events in equipment,
Yeah.
I always remind people that that equipment is properly applied, it's installed per the code,
Mhm.
and it is working as intended. When you have a fault internally, that's when things go outside of working as intended,
Yeah.
except for your product.
Arc resistant. That's what it's intended.
It's intended to contain it.
Yeah.
It's not intended to have the arc flash, but it's intended to say, if you have an event,
Yeah.
you're going to contain it, you're going to muffle it,
Yeah.
and now you're going to make it so that nobody in the room, they'll be aware that something happened.
Yeah,
Have you
but
ever
they'll be
witnessed?
safe.
Have you ever witnessed a test?
No, I haven't. But people on my design team
Yeah.
go to the test facility and watch it get blown up.
I would love to see those tests.
It is very cool. We have lots of videos of the equipment
Yeah.
getting blown up. Everyone loves an explosion. So
Okay, so hopefully on the channel we'll have a video of one of these in the future. Because what I'd love to see, like I have a video of our arc quenching technology,
yeah.
but I would love to show people that video of an actual test that shows the containment of that arc flash, because that's got to be powerful.
Yeah, I mean the room is shaking. There's like fire coming out of the exhaust ducts.
Yeah.
If you have exhaust ducts.
Now the doors
Pretty
don't
crazy.
look like my shirt after Thanksgiving dinner, do they?
No, I mean they're absolutely still intact. Like we talked
Okay.
about, they can't come off.
Yeah.
Nothing can be ejected.
Yeah.
But there's like some light smoke. You
I'm
would
sure,
have
yeah.
to absolutely evaluate your equipment afterwards.
Oh, that's another good point, because the internals would probably, it's like one of those things where you open the door and go, whoa.
Yeah,
You're-
definitely. You need to look inside, see what
Yeah.
it looks like. But I mean, opposed to an explosion, if your equipment actually
yeah.
explodes, your equipment in the whole room's probably shot.
Yeah, that's
and,
right.
And like you said, people are going to be safe. So I think that's the
contained
most
it.
important thing.
It's contained it, kept people safe and kept other equipment out of the trajectory range and all
Yeah.
that good stuff. So your replacement and your effort is contained to a specific area
Yes.
in the equipment.
Yeah.
I like it.
Mhm.
I like it. What else we got to talk about?
We could talk about the difference between the revision years for the ARC test.
Wait, the provisioneers?
Revision years.
Oh, really? I thought
that
this
sounds more fun.
Yeah, it does. It sounded like an Imagineer in
Yeah.
Disney, you know? I'm a provisioneer.
That sounds more fun.
It does. It does. All right. So what's that all about?
Well, so every year the standard's evaluated.
Yes.
And you have new test criteria that are created. So there's two big years for the C37.20.7
Right.
revision years. There's 2007, and there's 2017.
Okay.
So the 2017 revision is the one where, you know, a lot of changes were made to how you're testing the equipment.
Yep.
And that is what our AmpGuard Douglas is certified to. And
Okay.
we really push the importance of having a 2017 revision.
Gotcha.
In 2007, there was not a section for medium voltage motor control. You were just assuming that you were bundled under the switchgear
Right.
type of equipment. Additionally, at that time, where you initiated your arc on purpose at a test was at the most common point of arc flash, up
Okay.
to the manufacturer's discretion.
Okay.
The 2017 revision states that the most dangerous place, the most lengthy fault would be at the line side of the fuses. So they now in the 2017 say you got to test at the line side of the fuses because that's the most dangerous.
Ah, that makes sense.
So you could have something certified in 2007 and you still might not be catching the most dangerous case in your test.
Yeah, because you'll be downstream of an overcurrent device that's going to clear it.
Yeah.
Well, that makes oh well. You know what I say about codes and standards? It's like a fine wine, it gets better with time. Yep.
That's a good way to say it.
Absolutely. Okay, so there is a new requirement in the National Electrical Code that doesn't take an effect right now. They gave us a stay of execution a little bit,
Okay.
but it requires medium voltage equipment to be listed.
UL listed?
Yes, well, yeah, by a NERDL, but listed to a UL standard of whatnot, so I got to be careful there. But anyway, is our equipment listed?
It is.
Oh,
Yeah.
geez. Gosh.
I got you, don't worry.
Yeah, got you covered. I'm like, do I ask this question or do I ask this question? So it's listed, so that's perfect.
Mhm.
That's perfect. So, and what's really interesting is, in the past and right now, the code doesn't require it to be listed, yet we do that anyway. We get a third-party organization to review it, and then to your point, there's follow-up testing
Mhm.
and all that jazz. So it's an important piece of the puzzle to have somebody else look at look over the equipment.
Right.
Not all medium voltage equipment is listed, but a good majority I know of our products we go through that process. And I was a little worried when we were talking initially at the code panels about the listing requirements, but the fact that when I went down to the product line to your counterparts and I'm like, hey guys, there's going to be a listing requirement, they were like, that's great.
Yeah, no big deal.
No big deal. We're already there, so
Yeah.
that's a good thing.
Mhm.
Thank you for that.
Yeah.
Made my life a lot easier, and it made that question a lot easier too. But all right, so the difference in years, so older equipment,
Yep.
you may be testing it differently than the newer equipment to the newer standards. What else? Anything else?
Let me see what else I got here. Did we talk about drives?
No,
we did a little bit.
Yeah, a little bit. I liked, but I didn't think about this. But you say on the load side, I guess I'll call it the motor side of the drive is a lot less energy
Mhm.
and less voltage.
It has a lower incident energy.
It has a lower incident energy, probably because it's managed by the drive. I would think.
I believe it's because of the transformer, the isolation transformer.
Smarter than me. Okay, you got an isolation transformer in there and everything. So you're limiting the energy on the secondary, but on the primary, it's still medium voltage.
Yes. Yep.
And it's built such that you can take that portion and make it arc resistant.
Mhm.
And I love the fact that you can put it in an existing area and not have to worry about venting up and out.
Yeah. A lot of times we hear from consultants or like EPCs that exhaust ducts are kind of the last thing anyone's thinking about.
Right.
So it shows up at the facility and, the exhaust ducts go right through a cable tray. Like that's not going to work.
Yeah, no.
We get a lot of feedback that it's just kind of like not accounted for when designing new facilities.
Yeah.
So especially in old facilities, when you have all kinds of equipment on the ceiling, things you don't want to intersect,
Sure.
it's really crucial.
So who do you see buying it? I mean, do you?
Whoever needs motor control, really. I mean, if
Yeah.
you've got a mine, like we talked about,
Yeah.
and you're far underground and you want to protect people working in front of it, that's a great solution.
Yep.
It's very popular in water and wastewater, where arc resistant is frequently seen in municipalities.
Sure.
Where else? Oil and gas.
Yeah, those
Yeah.
guys are always up on safety and safety solutions and all that jazz.
Yeah.
And it's usually, like you say, it's your heavy. Those are people, because it's not a code requirement. So those individuals understand safety, understand reliability,
Yeah.
and they look for solutions like this.
Mhm.
I just wish more people, and it could be that people don't know about it, right?
Yeah, I think there's also a heavy, we talked about passive mitigation.
Yeah,
A lot of people prefer active mitigation, which is like arc flash relays,
yeah.
optical
And
sensors.
you could still put that in there, right?
Absolutely, yeah.
So
You
you
can have
could
both.
you could have the cake and eat it too.
Yeah.
You could say, look, I've got mitigation, and what that does is it makes sure that everything is contained.
Yeah,
And then if you have a fault inside, you may not have to replace everything inside.
that's exactly right.
So now you have equipment that, oh man, I like this. And I never thought, honestly, I never thought about it till just now, because I always had a love-hate relationship with arc-resistant equipment, because if the electrical worker, the moment you remove the doors, but you just educated me that I can have the control doors open.
Mhm.
I got to change my rhetoric whenever I talk about this in my 70E classes that I teach, because I'm always sitting there saying, it's not arc resistant when you start working on it, but
Yeah.
in this case it is the B, 2B, right?
2B.
2B or not 2B, that's the question. So 2B is the one where I can work on the control side of things and still have the arc resistance. So I think that's a critical piece. But if I overlay with that, say an arc reduction maintenance switch or zone selective interlocking or other technologies to address that,
Mhm.
now I am going to contain it and I can mitigate my loss. I
Yeah.
might be able to sit down and say, look, I'm going to bring Eaton Engineering Services back in, and we're going to clean this up. We're going to get it back up and running. I don't have to order another piece of equipment and wait 2 years
Yeah.
or wait, 2 weeks. I know this stuff takes a long time to get,
It does.
right? You just don't go down to Walmart and get it. So I don't have to put that on order, and I can get a field evaluation
Mhm.
to make sure that it's all functioning correctly
Right.
and be up and running quickly.
Yep, you're exactly right.
Layer it. I
Yep.
like layer. I called.
Layered
I was
approach.
talking to Mark. We were talking about layers of the onion from a
Mhm.
safety perspective.
Yeah.
The absence of voltage indicators and things like that are critical. But they're all layers of the onion from a
Mhm.
safety perspective.
Talking about layers, have you heard of exotherm?
Oh my! Who
Continuous
hasn't
thermal
heard of that? Are you doing continuous thermal monitoring and medium voltage stuff?
We do, yeah. We have exotherm IR sensors, temperature sensors
Yeah.
inside of medium voltage motor control.
So so that system health is critical. Gonna get you. System health is critical. That's he's a very important in the process of
Okay.
the electrical safety workshop, just like Lanny was. But continuous thermal monitor is critical for 70B and maintenance.
Yeah.
I didn't realize I know we're implementing all of that in a lot of different equipment, but you have it in drives. Do we have it in standard medium voltage equipment yet?
So we have it in like amp guard. Yeah.
Oh, you have it in the
medium
amp-
voltage starters, soft starters.
Oh wow, that's really cool.
Yeah.
So and then that communicates back through software, right?
Yeah. Same software that you would see with like Gear Guard, the one that was launched I think last year. So
Yeah.
it's called PDMC. So you could
Excellent.
have all of the Eaton equipment with your exotherm sensors on one software system.
That is fantastic.
Mhm.
So you can bring all that in. You can plan your maintenance. You know when you need to pull maintenance, when you don't need to pull maintenance. Got history.
Yeah. History, a look behind the curtain of what's happening in there.
What's the other technology that's big on medium voltage where it listens for sound and it's is it predictive diagnostics? No.
Listens for sound.
Partial discharge.
Oh, on wires, like partial.
Yeah, and bus work too. So when you layer all of those things together, you have the recipe for reliability.
Yeah.
The recipe for reliability. I'm gonna make t-shirts. All right.
Talking about exotherm. Here we
Speaking of
go.
which, you did that on purpose, didn't you? Thank you. Thank you very much. Enjoy the show. Try the veal. I'm here all week. Somya,
Tom, how are you?
I am good. How are you?
I'm doing great, thank you.
It's fantastic being in Texas at the Electrical Safety Workshop.
And you're here in March. That's the best time to be here.
That's exactly right.
You're not here in August, so that's fabulous.
Where's home for you, Soumya?
Austin, Texas, my friend. You're in my home.
We're in your
Yeah,
backyard.
you're in my backyard.
I knew that. I knew that.
Absolutely.
So why don't you tell everybody who Soumya is?
I'm Soumya Valangi, and I lead Exitum business unit within Eaton, and we do continuous thermal monitoring products for electrical distribution equipment. And I have been with Eaton about 4 years and running the Exitum business unit for about a year now.
Wow. How many years?
It's been 4 years.
Four?
Four.
Good.
Just 4.
Just
like
4.
I'm a baby compared to the rest of you guys.
No, you know what? I thought you said 40 years. I'm like, you're not that old to be 40 years at
I
Eaton.
joined as a baby, Tom.
We're hiring early these days at Eaton.
Early, yes,
Yes.
absolutely. Go Eaton.
Excellent. Go Eaton. I love it. So, continue. We were just talking medium voltage drives,
Absolutely.
and she was saying that we have continuous thermal monitoring in our drives as well.
Yeah.
So you're on a mission.
We're on a mission to be part of every power distribution equipment that's relevant to us. So from a portfolio perspective, we are in UPSs, PDUs, low voltage gear, medium voltage gear, MCCs, transformers, and I'm forgetting something, switchboards as well. So we're in all of the product portfolios. We also are now getting into bus duct products. So we monitor the joints of the bus ducts for temperature abnormalities, so we can capture failures early and do predictive maintenance.
And you commute now. We were just talking. We communicate with our software or anybody's software.
Absolutely. So we communicate. The data comes to our data card. Exitum has a data card where all the sensors send their data to, and the data card transports that data out our RS-485. So it can go into any of the SCADA, existing SCADA, BMS, DSIM systems, or from our own portfolio, we communicate through the PXQ platforms and PDMC platforms up into BrightLayer and Foreseer as well. So if you have any of our head-end software systems, we have drivers to send that data. So not only you can see the data and you can see the trend, but you can also action when things are not going well. When there's an alarm or a warning, you can go take action and fix the problem early.
Awesome. So do I have to buy new equipment with it in, or can I retrofit it into existing equipment?
All of the above. All of the above. So
I love it.
The best solution is to get this done with the OEM. So if you're buying new equipment, spec it in and get it in with your OEM so you can get it with the new build. It's very easy to retrofit. Somebody like me that is not an installer can do it under 5 minutes.
Really?
The motor control center is our simplest solution. It zip ties to the terminals, the incoming and outgoing, and it takes about 5 minutes to program the data card. It's very simple to retrofit, but it does require us to de-energize the system and take the equipment down.
Thank you.
So from an equipment point of view, retrofit is possible, but it does have to coincide with especially in mission critical environments where we recommend this product, we need downtime. And that usually doesn't happen, especially if you're a data center, if you're an oil and gas refinery, you don't want to shut it down to put these kind of systems. So it's very wise to get it on new builds, but you can also retrofit. If you have scheduled maintenance, after 5 years of runtime, you're bringing it down. Take the opportunity to put it in because you're keeping your people safe, because they don't have to go around and do the thermography scans. They don't have to open the equipment and cross the arcflash boundary. So from a safety perspective, from a reliability perspective, and from sweating your assets longer because you're now detecting failures early, you're doing the sustainability piece of things as well. So those are the 3 outcomes CTM provides for you.
That makes so much sense. And yeah, I'm glad you said establish that electrically safe work condition. And when you're right, that when you're performing maintenance, you're going to take something down, you're going to establish electrically safe work condition. Your people are going to get in there, clean the gear and do all the physical. They have the mechanical tests and whatnot. Take that opportunity. You put those terminations and you select it and get it around those terminations. And then when you put it back up, you have the data. And then you can strategically pick what equipment needs attention over what equipment may not need attention.
Absolutely. Absolutely.
I like it.
It is one of these technologies that is so simple yet so impactful.
Yeah.
And that's what I love about this technology is we have patents on all of these. They're super simple to install. The sensors, they are in the booth for display at the show here. And they're one of the, I call them the little miracles because they detect the problems and they only show you the problems. One of the beauties that we have compared to our competition is we have a patent on something called delta T. So instead of giving you the ambient temperature of the joint, we give you the difference between the ambient and the delta T and the joint. So
Right.
that means we're only giving you an alarm if there is a problem at the joint. If
Ah.
like in Texas, it gets hot.
Yeah.
You don't want an alarm just because
It's hot.
It's 105 degrees outside, right?
Right.
So we will give you the difference between the ambient and the joint temperature, and that's when you know it's a real problem.
So that's a temperature rise.
That's only rise. Yeah, that's what we give you.
I like that. So that way, and then you don't. That's one of the issues I had with thermography.
Yep.
Was I think you have to be a a doctor of thermography to read a thermography picture because it's I take a snapshot and I go, well, I see this is hot, that's not, but maybe it's okay
Yeah.
because equipment gets warm. But when you're measuring the change, the difference in temperature between ambient and that termination, now you've got something to where if it gets too far apart, you've got an issue
Absolutely.
because your ambient can be high.
Yeah.
I like. Now, how big are they? I mean, can you put them in panel boards?
We can put in banner boards, but we have a cable solution that we can put in. Typically, depending on the spacing that you have in the cabinet, for the IR sensors, we require a little bit more spacing. So
Right.
there's not enough space in a panel board, which is footprint constraint.
Got
But
ya.
we can definitely put in a cable solution there.
Excellent. You say a cable solution.
And one other thing, when you said thermography, something very interesting to point out is thermography is a point in time. So when you go around, depending on what the ambient temperature is, as well as the load,
Yes.
you get a point in time. If you do once a year, that's one snapshot in 365 days.
Yeah.
What these sensors provide is 24/7, 365 days, and it gives you under all load conditions. So your load can be at max or min, and
Right.
that's a very important determination when it comes to the joints and how critical the heat gets.
Yeah. Oh, microphone up. Oh, there we go.
All right.
All
sounds
right.
good.
Yeah.
Is it better?
Perfect. So, okay. So, I'm with you.
So,
We have solutions for everything around. Order with your OEM.
Yep.
And you have a continuous. You see the whole history. So if something is creeping up,
you see the whole history, and we set an alarm in the system so you can see the change. And when it hits the warning level, you get an alert. And when you also can set an alarm, and it'll give you an alarm at that point. So you can take action, different kinds of actions when you see those different levels hit.
excellent. And do we have a software application that reads it and gives us?
We
and-
have a local HMI solution that
Oh,
reads
okay.
it and we have an LED solution on MCCs that can tell you locally what the problem is.
Right.
We also have the local HMI where you can web into it. It's web enabled.
Oh yeah.
Or it can go into any of your
Building
BMS,
management.
SCADA, whatever your existing system is.
Yeah.
Um,
Probably many different protocols.
Yeah, we want to be industry standard. Whatever the customer has, we want to be integrated into that ecosystem.
Gotcha. I gotcha. Now that makes a lot of sense. That makes a
Yeah.
lot of sense. So it sounds like an exciting. Are you excited for it?
It is super exciting, and I'm also very excited to share another new product with you guys. We launched bus duct monitoring system. So especially when you're transmitting power and distributing power over bus duct,
Yeah.
these bus ducts are connected at the joints in the field. And we have bus duct monitoring sensors that go on these joints that not only capture the joint temperature, but also capture the adjacent joint. So now you know if this particular joint is getting heated compared to the next two.
Oh wow.
And also the average of all of them, because we can connect 8 of them in series. So this is something that we really aspire to hit the market this year with. Data centers, any
Oh, yeah.
semiconductor industries where they're transmitting power using bus duct within the power distribution infrastructure, that's our target market. And I think the few pilots that we have done, tremendous success.
Oh, I'll bet.
Tremendous success
I'll bet it
because
has been.
most of these bus ducts come in different lengths. They're custom length because
Yeah.
your layout is different.
Right.
So that is one thing that you don't keep a spare of.
Ah,
If you
yeah.
don't keep spares, you
Oh no, yeah.
the entire infrastructure is down. You know that,
and if that bus duct goes,
Then
that's
you're
giving
down.
power to everything.
right?
So you want that early awareness, and you
Yep.
want to know you may have to plan an unplanned maintenance
Absolutely.
because you're watching the temperatures creep up, and you say, "Hey, this doesn't look good.
Absolutely.
I need to do something to address it."
And then imagine these bus ducts, they carry a lot of power.
Yeah.
And when they blow up, it's definitely damage to the equipment. And if there's people nearby, it hurts people as well from a safety point of view.
Absolutely.
So this is another product we're super, super excited about.
Yeah. So do you see? I know we didn't plan any of this, right? So,
Yeah.
although
We're winging it.
we're winging it. Do you see artificial intelligence playing a role in your product line in the future?
What do you think, Tom? The answer is absolutely yes.
Yeah.
What I learned is before you do these inspections once a year, that was enough because the load was pretty standard.
Yep.
But with AI, it's very cyclical loads. That means sometimes it goes up, sometimes it goes down,
Right.
and it goes up, it goes down. What that means to the electrical equipment and the joints is it gets heated up and
Right.
cooled. Heated and cooled. That means it gives you loose joints,
Yeah.
and loose joints create arc flash risk, etc. So we think that as AI infrastructure is getting ready to take off,
Sure.
these problems that used to happen once a year, twice a year, now will happen more frequently. So the annual thermography is no longer going to be enough, and you need something like a CTM solution to be ahead of the curve.
Absolutely. And you could take that temperature data.
Yep.
And just think, if you had an AI engine that had the whole history and said, boy, when you first installed it, the temperature was here, and now it's, and 5 years ago it went to here, and then here's where it's at now, and it plots that and analyzes the data, you might be able to say, here's what the problem is,
Correct.
or what it could be.
And how do I manage my loads accordingly? Because now we're no longer just playing in the gray space. We're taking this data into the white space and making decisions.
That's
And
right.
that is the game changer for us.
Yeah, because it's not just about you're marrying the current, the voltage, the turning things on and off, the dynamics of the loads. Now you can take all of that information and see how it relates to it. You can have
Absolutely.
AI sit down and say, look, your temperature was this, but your load current was here. Your load current went up to here, now your temperature went to
Temperature,
here, and draw the relationships.
We have a patent on something called a load map that does exactly this. And we
Really?
have it in our HMI,
Yeah.
where we have a patent on the delta T's corresponding loads. And we do webinars all the time in terms of how low load conditions are
Yeah.
important from a safety perspective.
So I can't get on a patent, just coming out with the idea.
Coming up with ideas now,
Yeah.
we'll work on a different patent.
Okay, we'll work on a different patent. All right. Well,
I
that's
think-
pretty cool.
Yeah, one of the important things, I think, because this is ESW, we're streaming from here, the NFPA 70B and the code changes that you're intimately familiar with, that
Oh, yeah.
I think is very important for this audience as well.
Yeah.
Because now for the joints, from an electrical maintenance point of view, you no longer are required to do thermography. If you have these sensors monitored, you can determine your own schedule for maintenance, which is a huge win from a code perspective, because I love how code came up to speed with the changes and allowed for these technologies to be widespread. Because
Right.
before, this used to be a cost.
Yes.
I had to do thermography and I had to do these CTM sensors. Now, it can be either or. In some cases, you can reduce the thermography inspections to a lot minimum
Yep.
and get by with CTM. And that is a code change that I'm also super excited about.
Yeah, me too. That was a 70B change, and it was, as codes and standards starts to recognize innovative solutions, and
Yeah.
and I'm a firm believer that there is I know in the data center world, for example, this is a point of discussion,
Yeah.
and I've heard people say codes and standards is a barrier to entry.
Yeah.
And in my opinion, it's as long as the code does not prohibit,
Yep.
I'm allowed to install, and you don't want to inhibit your creativity by making a mandate on a technology that doesn't exist yet to standards that don't exist yet.
Yeah.
So you want innovative solutions to come to the market, working with installers and maintainers and others to make sure that it's a good, safe, and we could go to UL Solutions and other in nationally recognized testing laboratories to ensure a safe installation practice in assemblies and whatnot.
Yep.
And then you overlay codes and standards of that and say, look, this is a great technology. It can mitigate and save lives.
Yeah.
And then you have good, honest discussions at the table to say, should we mandate it? Should we maybe put it in as an option?
Yeah.
Or an alternative?
Yep.
And that's what we did in 70B with this technology. We said, yeah, thermography is one thing, but this technology is a way to get the person out of the arc flash boundary.
Yep.
You don't have to expose them, because even OSHA says the mere act of establishing an electrically safe work condition is justified energized work.
Yep.
So you still have to, you're still putting your person or your individual into an environment of justified energized work.
Yep.
To verify absence of voltage, and you don't have to.
Right.
And then to your point, it's a simple solution. It's not hard to install.
Yeah.
And you volunteered to install these across the country yourself.
Absolutely. Let's go on a world tour, install this, not
Oh
just
my
across
gosh.
the country.
We could get a van.
We could get a van and go install these ourselves.
I love it. I love
Tom
it.
Insomnia Company.
Tom Insomnia. I love it. I love it. I love it. Well, that's awesome. That's awesome. So what else? What do we have? Anything? Are there good, cool solutions?
From a solutions perspective, we have just these IR sensors that go into all of our products, cable sensors that go into our products as well. And then the motor control center is another exciting part.
Oh, yeah.
That's in the display here, and Steven Zip is going to be here to talk about MCCs as well as Exotherm within MCCs, which
Yeah.
he has commercialized recently.
That is awesome. And motor control centers, I mean, if I look at statistics and you think about equipment that I wouldn't say is dangerous. We interact with motor control
Yeah.
centers a lot more frequently than, say, a panel board or a switchboard.
Yeah.
Because you're constantly pressing buttons, you're doing things, maybe racking buckets out, putting buckets back in again. So it's a very interactive solution. And when you have something that you increase the interaction, you're going to have a higher likelihood of something happening.
We've visited a couple of customers in the last year that love motor control centers. They have thousands in their country. And one of the safety concerns they have is these motor control centers blow up. They have no idea why.
Yeah.
And the customer had our product in his hand and could not put it down because he said this is exactly what he was missing to understand what goes inside that box, because you can't see it.
Yeah.
You typically don't have an IR window with a clear line of sight to all the entry points in there because it's pretty close space
Sure.
and it's very dark and it's kind of very hard to understand where the fault is. So
Yeah.
having these kind of sensors is a super simple solution to having data to keep your people safe and to keep your equipment safe.
Oh, absolutely.
Yeah.
It's a no-brainer to me, and it's one of those things that I never installed them, but if you're telling
fix
me,
that problem.
I know. Why do you think I asked if I could put it in a panel board? Because I'd put it in the house.
Yes.
But I think there's a lot of opportunity for continuous thermal monitoring, CTM.
Yep. If you safety, uptime, and sustainability. If you care about those three outcomes, you should look at CTM as an option.
And I know everybody's going to now.
Absolutely.
And
Happy
so-
to help.
I love it. I love
Yeah,
it.
it was
What
a great
else?
conversation, Tom.
Yeah,
I hope your viewers enjoy it, and if they need more information, we're here to help.
We are from Eaton, and we're here to help.
Absolutely.
Excellent, Soumya.
Thank you. I'll pass it off to Stephen.
Perfect. Give me a handshake. Always good to see you.
Same
Thank
here.
you. All right, we got Robert. For pressure terminations are almost always the first to be damaged by heat because thermal expansion. They are typically rated 75 degrees C. Yeah, and Yep, product name for bus duct. Where's it at? I'm just, oh boy. All right, boy, you guys are chatting up a storm here. I really appreciate this. Oh my gosh, we got Eric Stromberg in the house. Which one's coming in? Pick my poison? I don't know. Well, let's do this. Wrestle. We're trying to figure out who's coming in and who's not. Or we got one of these guys. He was waiting. Come on in. All right. What about cybersecurity? Oh, we're going to talk cybersecurity, Robert. All right. 5 minutes. We got 5 minutes with him. Holy cow. What's going on?
How you doing?
Derek Vigstel,
How you doing?
the Vigmeister J.
That's me.
Excellent. It's good to see you here.
It's good to be here. It's good to be seen.
Man, I tell you what, and I know everybody out there knows you from our Shock Week
Yes.
series of unbelievable. That was
I'm Derek Vigstall of Shock Week fame.
Shock Week fame. So
Yes.
Derek, why don't you tell everybody a little bit about your background?
So, I'm an electrician by trade. Grew up in the Minneapolis area. Got into teaching at a JTC in Minneapolis, and then played a little trivia game show and got a job at NFPA as the sort of man behind the curtain at NFPA for all things electrical, and
Yeah.
and then jumped out there in 2021, and now I'm doing the consulting thing. Spend a lot of my time on mainly on safety and 70B now with the maintenance.
Yeah,
role.
you know, we were just talking to Somya, and we have a continuous thermal monitoring system
Yes.
that well, it's by name continuous.
Yeah, that means
And-
all the time, right?
You know what? I'd have to look that up.
That's why they pay me the big bucks,
That's
Tom.
why they pay you the
Yes.
big bucks. And it and data is so important when it comes to maintenance.
Yeah. Well, that's what when I've been going out and doing assessments for maintenance 70B stuff. That's why I've been teaching people. Look, as you start to build a maintenance program,
Yeah.
you're becoming little electrical system PIs is what you're doing. You're just digging into the information, and that information is key. And that's why I think a lot of places with these that are building out their maintenance programs now are learning exactly like, oh shoot, we need a CMMS. We need a maintenance kind of somewhere to collect all that data so we can hang on to
Yes.
it and track the trends over time. And that's where we start to get into really effective maintenance programs, is when we can track the data over a time period to see, this is like when you go to your doctor,
Oh,
like they
absolutely.
pull up your chart and they look at
Yeah.
what you were last time so they can see what you are today and say,
Yeah.
okay, hey, maybe try some stretches in the morning, Tommy. And
I think I need more than stretches in the morning.
Me and you both. Yeah. Yeah.
Jeez.
Yeah.
But no, you're right. Maintenance is critical, and you do a lot of education, a lot of teaching.
Yes. Yeah.
You develop
And
books, or you?
So yeah, I mean, my hobby and my spare time is I write a couple textbooks for trade schools and stuff, but spare time is hard
Yeah.
to come by these days. But yeah, I mean, primarily what we're doing is training and consulting on the services
Right.
for the codes and standards stuff. So that's primarily what we do. But it's all about keeping people safe, and that's really the way I approach it. And maybe we can talk about this quick here, but I've been looking at how 70B and the maintenance side of things plays into the arcflash study, right? Because those are all those numbers
yeah.
in the arcflash study are based on clearing times.
Yep.
But if you haven't done maintenance, what's the clearing time?
You don't
of
have
that
the clearing
breaker?
time.
Right.
Yeah.
So I've gone into a lot of facilities and they have these elaborate arcflash studies all throughout their site, but are they accurate?
Right.
And that's the question we're starting to ask now on the maintenance side. Say, is this an accurate study? Are we really doing what we need to do to provide a safe working environment?
Yeah.
And so we got some work to do now. So
Yeah, we do. And so that relationship, and I've had people say, well, 70B is not adopted and it's not enforceable, and and I go back to 70E and say, well, you can't have 70E if you don't have maintenance.
Yeah.
And yeah, maybe 70B is one of your references, right? It
Right.
doesn't have to be the reference, but 70B is laid out much like 70E, where you have to build your plan for
Right.
maintenance, and
Right.
it's not that you're following 70B, it's you are building a maintenance plan.
Yeah, and also, like, obviously I've been doing a lot with 70B, but
Yeah.
it a lot of times comes back to what the manufacturer recommends.
Well,
that's-
70B even says it.
Yeah, that's what the ultimate goal is, right? Like,
Yeah.
you may have not done maintenance for a while, so we're going to use 70B to get you back to normal operating condition, and then from there go back to what the manufacturer recommended in the first place
Yeah.
that you should have done from day one. But some knucklehead electrician came and installed your system and forgot to tell you, oh, by the way, don't forget to change the oil on it.
Yeah.
Yeah. And so
I when last time I bought a vehicle, it has a booklet, and I can't remember if the sales guy told me I should change my oil.
well, now maybe you got somebody to fall back on.
Yeah.
Yeah,
I'm going to say Derek Vixel said. I love it.
All right.
It's all good. Yeah.
So,
It's good to see you here at the workshop. And
yeah, like I said, this is such a it's always good to be seen here, and this is my favorite conference of the whole year.
yeah.
Not the biggest, but it is by far in my mind, as a safety guy, it's the most fun that I have all year round. And well, work-wise anyways.
Yeah, that's
right?
true.
I mean, my daughter's a competitive cheerleader, and we go to Disney World every year. So I mean,
Oh,
yeah,
my
I might have a
gosh.
little bit more fun there.
Jeez.
But I absolutely love this conference, and anybody looking to further their knowledge of electrical safety and get into this type of work,
Yep.
this is a must on the
Absolutely.
calendar.
Yeah. I had Lanny here, and Lanny made the statement, it's not just for the electrical, it's anybody in the safety profession,
Yep.
anybody out there in the industry who's worried about safety should be engaged with this
Right.
event, because it's not just about the presentations.
No.
It's all the people. It's the Derek Vixtels of the world, the Lannys, the Dilip Molas of the world, and
Tom Dimitrovich is.
I don't know. I
come
wouldn't
on,
go that
don't-
far.
Don't get you don't get off the hook quite so easy,
I don't know
sir.
about that.
Yeah, but
But no,
yeah,
it is.
It's a great networking opportunity.
It is. It's a great networking. You build your relationships. Like I met some people from the UK,
Yeah.
and I found out they have a monthly call with data center people, and they talk about safety.
Yes.
And I'm like, okay, this is there's people here from the UK, from
I think Australia's here.
Australia,
Yep.
and what are the guys over here? They're from Finland.
Finland. Yep,
Yeah.
we got Finland.
Got Finland.
I've spoken to a couple folks from Africa now, kind of getting into the safety aspect of things. So we got people from all over the world with one common interest of keeping people safe from electricity, because that's the end goal. I mean, everybody knows electricity can do some damage. You can get hurt,
Yep.
but it
And-
doesn't have to.
And Derek's going to be on Shock Week at the end of May. We're going to do some videos. He's coming into Pittsburgh, and we are going to have a great conversation.
Yeah.
And you wanted to focus on maintenance, right?
I do want to focus on maintenance for Shock Week. I want to get into how intimately tied into safety maintenance is.
I'm looking forward to that.
And really take a look at what a company can do, or what owners of electrical equipment can do to get started on building that maintenance programs, especially if that's not something they have, right? If they're standing with an empty 3-ring binder right now going, where do we go?
Oh, yeah.
What are we supposed to do? How can we give them something to kind of get that jump started? And it's like I always say to my clients, look, you don't have to see the whole staircase to climb it.
Right.
You just need to take the first step. So let's give them a little bit so they can get started.
And you
on
know
it.
what? You can do it with them.
Yeah, absolutely.
They don't have to be alone.
Yep. I'm always pumped to talk about this.
I know
stuff.
you are.
So all you got to do is give me a phone call.
You got a face for radio. You know that.
I do. Yeah. And then you bring me to the booth and you put me on camera.
I
so-
got to.
Yeah.
Thank you.
Hey, man.
I really
It's
appreciate
always
it.
a pleasure, sir.
My
And,
pleasure.
and thanks for having me.
Thank you, sir.
Take care.
Stay up. Stay safe. Stay safe.
Will do.
Yes. We have. This is Stephen Zipf. Holy cow! You're another man with one vowel in his last name.
You got it.
Awesome.
The P is silent.
The P is silent, so it's Ziff,
Ziff, yeah.
not Zip.
Mm-hmm.
It's
You
Ziff.
always know when a telemarketer's calling.
Yeah, that's a good way to put it.
Yep,
All right, so I'll let everybody know up there who you are and what you do.
absolutely. So Steve Ziff, like Tom said, I'm the associate product manager for our low voltage MCC product family. So Been in the role about a year now. I came
Okay.
from our surge protection and power factor correction business. So yeah, really happy to be here. I've got a power quality background and really excited to be in the MCC family and kind of showcase what we can do.
Well, that's pretty cool. Where are you located at?
Right now I'm in Fayetteville.
In Fayetteville,
so yeah, I
excellent.
came out from Pittsburgh and
Yeah,
moved my way down there about a year ago. So
Yeah, well, I'm
really
sure you'll
excited.
come back. Everybody who's in Pittsburgh always comes back to Pittsburgh. So, you
Yeah.
know, I was born and raised in Aliquippa, PA, and I left, and I went to Florida, and I went to Reading, I went to St. Louis. You always come back.
I always come back. Yeah.
Absolutely.
Yeah, the wife loves the winter weather down here in Raleigh, so
I'll bet.
It's going to be hard
Bet.
to convince her otherwise.
Yeah. So motor control centers, and I was just talking to Somya.
Yeah.
And she was saying how she has continuous thermal monitoring in our motor control centers.
Absolutely. Yeah.
And that's got to be exciting for you.
Exactly. Yeah. No, it was a great product launch that we were able to come up with last year. Being able to integrate our Exotherm family of CTM sensors into an MCC bucket. We have both aftermarket and traditional MCCs directly from the factory that we can build.
And I was just asking her. So, she was talking about these sensors and how easy they are to install.
Yeah.
And then I was asking, well, can I retrofit that?
Mm-hmm.
And it's easy apparently, impossible.
Yeah.
I mean, are they wired in? I mean, what do they do? How do you?
Yeah.
Do you have to take wires down through the motor control center? What I mean?
No, it's somewhat simple. You have so 2 sets of sensor looms. There's 6 individual sensors total.
Okay.
What we do in the factory is we take those 6 sensors. We do 3 on the line side of the breaker.
Okay.
And zip tie those to those actually incoming cables.
Okay. Yep.
We also do the output of the bucket. So that's kind of what we do as a standard. But if the customer wants, we can also do line and load side of the combination starter. We can kind of make it as a la carte as the customer wants. So if they want to monitor every load that they can possibly do, line and load side of the breaker, line and load side of everything, we can do it.
Excellent. So you can, and then it's all continuous. You have a local display on the motor control center?
We do, yeah. So that's our data display unit, we call, and that can be directly on the MCC.
Yeah.
It can also be communicated just through Ethernet to a SCADA system. So, if you don't necessarily want something directly on the MCC, you can still feed that into your communication backbone. And
that's smart. That's smart. And all cyber secure?
All cyber secure.
Yeah. Somebody had asked the question. I think it was Robert from Omaha. What about cybersecurity? And finally, Robert, we got to it. Yep, that's perfect. Oh, great to see Derek from Shock Week. We just had him. Yep, that was Steve talking about that. So what else on now motor control centers? I know we have the ability to rack the buckets out and in with the door closed.
Yep.
Is that right?
Yep, that's our flash guard product.
Flash guard.
Yep. So yeah,
Flash
you
guard.
can stand 25 feet away, safe from the arc flash boundary. You don't have to wear any PPE.
Okay, so do we have that a bit? I remember when we first came out with it, and I was talking about it, and I said, "Oh yeah, you can put this on the front and rack this out remotely," and they were like, "No, not yet, Tom." You know.
Yep.
So we have that, right? So we can remotely take these things out of the bucket.
Yep. So it's a device we would install on front of the bucket.
Yeah.
It would be a pendant that we can take 25 feet away.
Press the button.
Press the button, and
I like that.
Disconnected from electricity.
Yeah, that is so. And people ask me, what are we doing to from a safety perspective? And I keep saying we're doing more with the doors closed.
Exactly.
And now we got continuous thermal monitoring with the doors closed.
Exactly. So that's the next step up. Where your arc flashes are going to happen. It's going to be either when you're installing the gear, maintenance. If you're running and that motor's on and going, you're typically not going to see an issue. Really, it's when you're doing those maintenance operations. So having that exotherm sensor capability, you can really see, okay, my line side connections are hotter than my load. What's going on?
Absolutely.
An issue
and they
there.
do difference. So she taught me something. They do the temperature difference between ambient and the termination, which is a lot better than just the temperature of the termination.
Exactly. Yep.
Whoever came up with that simple idea, it wasn't me.
Brownie points to them, yeah.
Yeah, exactly. Brownie points to them. Or I remember years ago they used the term kudos. And I was like, I went home and I was like, what the heck is a CUDA? I had to look it up. But anyway, what else is going on with MCCs?
Yeah, so obviously we've talked a lot, kind of want to focus on safety. So we have a ton of new arc flash products available. So we have obviously our arc resistant MCC. We
Yeah.
have expansion chambers on either end of the MCC to really hold that blast in. So it's a 4-inch chamber on either side.
Really?
Yeah. So
Okay, so I learned something today about a 2B. 2B? The standard has a, now this is for medium voltage
Okay.
equipment. There was a 2B test that lets you open up the control and circuits, but I guess you wouldn't have that on a motor control center because you don't have a separate compartment for where you have control wiring because it's all inside the buckets.
no, yeah, it's
Yeah,
a bucket.
yeah.
We do have the vertical wireway, but this would be in addition to that vertical wireway.
Okay, so you call them bellows? What'd you call
No, I guess it's just an expansion chamber.
Expansion chamber,
So
okay.
it really just allows that gas to expand. Get some
Okay.
thicker steel and some different hardware to really
Does
hold
it
that.
vent into the room?
Nope, it's all kind of.
Oh, so there's no venting
There's
on
no
it.
venting. It doesn't need to exhaust anywhere.
Oh, okay. So that must be the low voltage assemblies have to take the energy, the power up and out. But when you deal with your products,
Mhm.
you can just contain it all.
Containing the blast. Yep.
Well, that makes sense. That makes a lot of sense. Is now? At one time, I was telling somebody about a product, and I went down to the product line, and I was like, "Man, this would be a great idea." And they said, "We've had that product for 4 years, Tom." And I'm like, "Oh boy." So how long have we had this product? Is it new or is it?
It's
been around.
years old. It's been around.
It's been
definitely
around.
been around.
All right.
But we have had some recent additions to what we can offer in an arc resistant MCC. So
Oh, really?
we can now offer up to 2,500 amp Magnum breakers, which is an addition for us. Historically, it was up to 2,000 amps, so it gives us a little more high end volume there.
So you have a motor control center with a Magnum breaker in it.
Yep.
And that would be an insulated case circuit breaker, not a power breaker.
Yep.
But I don't know if anybody out there understands what that means. I mean, I know what a Magnum breaker is. I never realized, I guess I should realize. I thought that motor control centers were just motor starters with contactors, but you can do a lot more in a motor control center, can't you?
Yeah, there's a ton you can do. You can do, obviously you mentioned combination starters, but you've got feeders, there's fusible options, we've got drives, soft starts, metering, Ethernet. We kind of cover everything.
Wow.
We kind of call it the Swiss Army knife of the electrical package. We can do a little bit.
Yeah, I remember when they took switchboards and they made it an integrated facility system and they put a transformer in there and they did other things. Can you put a transformer inside you can?
We certainly can.
Oh my gosh.
We can do panel boards. We
That's
can do
insane.
Yep.
So,
right.
so the product standards for motor control centers gives you a lot of flexibility.
A ton. Yeah, it is. I would say it's a very challenging. This UL standard that we adhere to is UL 845, which is a very tight standard that we have to follow.
So it's a listed assembly. It's listed.
It is. Yep.
And I learned something from Matt Hussey.
Okay.
What Matt taught me was that each bucket is listed.
Yep.
I never knew that.
Yeah.
I did a retrofit down at a plant, I won't say where, before my life at Eaton. I was consulting. And we had a big facility, had a lot of motor control centers, and we would take the bucket out. And what we did was we did the drawings, and we had a bucket that was made, and we assembled the bucket, and then we would take the old bucket out, put the new bucket in, and then re-energize.
Yep.
Technically, we should have gotten those at least field evaluated or went back to the manufacturer and made sure they were listed assemblies.
Yeah.
When I learned that, my jaw hit the floor. I was like, wow.
Yeah.
That's
Yeah,
amazing.
Yeah, our UL standards definitely allows us to do a ton of things, but it certainly keeps some good guidelines on what we can and can't do.
Gives you guardrails.
Yeah, absolutely.
Yeah, you got to have guardrails, else you get scope creep and you become a switchboard.
That's true. That is true.
Man, so you can put insulated case circuit breakers inside. I guess, and those would be feeders for downstream.
Yep, that's right. And we actually this past year came out with the Magnum offers the PXR trip unit, and we can now offer that in an MCC as well. So having that PXR trip unit, as well as power defense as well, was a new addition last year.
Yeah. Power defense, PXR. Whenever I hear PXR, there was a company that did they were in the movies, and they did color or whatever, and they would say colored by. It wasn't PXR, but it was something
Okay.
like that. But
Close to
anyway,
it.
whenever I think of PXR, that's what I think of. But in any case, I diverge, I diverse, or whatever. So, motor control centers. Have we implemented the arc quencher yet in a motor control center?
Not yet.
Not yet?
I will say it's something we're actively looking into.
That would
for
be
our
cool.
New product development, but not ready to go
Yeah.
to market yet on that.
Tell,
one.
from Tom, just tell the product line which I'm talking. So wait, what was your role again?
Associate product manager.
Associate product manager. So we
Yep.
have associate product managers here. So
Yeah.
what did we call those? Back when I started in '96, we had product engineers, I think they called them,
Yeah.
and then they reported to the product manager. So now you're an associate product manager.
Yeah. Same type of role. Stan Frady is our product manager. If you know Stan.
Yeah, I know Stan. Yeah,
Um,
yeah.
So yeah, I just help him with a lot of our marketing and kind of launch activities, helping
Yep.
him with getting our roadmap set and
Yeah, yeah.
really
So
building
that's
us up with projects.
it's a great position.
Yeah.
And so you said you moved down there from, no, you didn't. Yeah, where were you at before?
Pittsburgh.
You were in Pittsburgh. Yeah. You're still in Pittsburgh. No, you were in Pittsburgh and you moved down to Fayetteville. That's
yeah.
right. So that's the cool thing I like about Eaton.
Mhm.
I know I've been here for 30 years and I've had different roles. Now, I only had to move once. I went down to St. Louis
Okay.
for the busman after we did the acquisition of Cooper.
Gotcha.
But Eaton gives a lot of great opportunities to change roles,
Mhm.
get different experience, and what you really want is an individual who's been to different divisions.
Yeah.
Because then you get well-rounded
Yep.
and understand the business a lot more.
Absolutely.
You
Yeah,
like
I know.
you like what you do now?
I love it. Yeah. You know,
Yeah.
I came from,
Surge.
Surge and application engineer, worked my way up to kind of a sales engineer role and
Sure.
into product management. So it's been great having that technical background I can really rely on.
Yeah, yeah, yeah.
I like having that power quality background as well. Not
Yep.
just, okay, let's install everything we can. We can start-
Sergio.
yeah. We can,
You know Sergio Panetta? I got to get him soon.
okay.
But I don't want him to. He keeps walking by and he's like a shark, you know.
That's
And I
right.
always want to make sure he knows.
Yep.
But so you've been in different roles, and you're enjoying the motor control center world. And
I am.
how do you like Fayetteville?
Fayetteville's nice, yeah.
Yeah, yeah, yeah.
I live in
Beautiful.
between Fayetteville and Raleigh, but
Oh yeah, yeah. Beautiful
it's a
country down
beautiful
there.
Area. Beautiful.
Beautiful country. So what else is going on in motor control centers?
Yeah, so we've hit a lot of the topics.
Okay.
Definitely, like, power defense was a big one for us. It's
Yeah.
the amount of testing we've had to do to get that product launched is
Now those breakers have circuit breaker health on them too.
They do. Yep.
I mean, so that's the other cool thing. I just got goosebumps because what happens is you take these products that each individual component is adding technology, like continuous thermal monitoring. Circuit breakers have circuit breaker health. They'll tell you how many times they've opened and closed, interrupted, what the fault currents. But once you integrate that with your assembly, you get all of that value
Exactly.
as the product line, and then your customers get that value because now they're not just looking at a standard motor control center, they have technology that adds a lot more value.
Yeah. Yeah.
That's
No,
phenomenal.
we work in very close concert with our ICD and our component level
Yeah.
groups to, okay, what are their products that they're coming out with in 2 to 5 years, and
Right.
how can we integrate that into our gear so that their improvements are also ours, so it really helps us work as one
Yeah.
Eaton and really get that.
Absolutely. It's you. I always say you got to wrap steel around it.
Yeah.
You just don't sell a component. You got to wrap steel around it,
That's
and
right.
you're the steel, and you bring all of that value all packed in, and
Mhm.
and then your challenge, I know because I've been in that role before, is to develop the marketing and help
Yeah.
people understand the value
Exactly.
propositions and
Yep.
and understand the return on investments and all that good stuff. And
Yeah, you can come out with 100 different product launches, but if they don't understand where it'll benefit them and what they can use it for, it's worthless.
that's right. And your hope is to get it spec'd in.
That's right. That's right.
Absolutely, and that's
Yeah.
our job.
Yep.
Cool.
Yeah, so we've got that, and then the only other thing I wanted to kind of highlight were some
Yeah.
of our compact offerings.
Oh.
So we have a new to the market, and it's actually the smallest footprint in the industry right now in MCCs is our compact dual feeder. So that we came out with last year. It's two 60 amp PD1 breakers
Yeah.
in one 6-inch space. So it's really lets you get very dense. You can get up to 24 in one vertical section.
Wow.
Definitely.
And I know heat had to play a really big obstacle to get that to pass
Yeah.
the standards.
The thermal
And
testing was very difficult, but
I'll
we
bet
got
it
that
was, but you got it done. That's
it done.
pretty stinking cool.
Yeah.
And and it's all listed.
done. All listed.
Thank you for having it listed.
Yep.
Cool.
Well, thank you very much, Tom. I
Oh,
appreciate
thank you.
having us on.
I appreciate you coming in, and you got to get to the booth.
I
And
know.
I was hoping to have Sergio, and he left again. Dadgummit.
Thanks again.
All right.
See you guys.
Take care. Thank you. Enjoy the show. Jeff, what's going on? Good to see you. You're the man, the legend. Back-clad medium voltage switchgear.
Yep. I actually have some representative clothing from my product line. I have so many Eaton polos at this point. I was like, I should probably pick one that's the product line I'm in now. 'Cause I
Yeah.
have like an LVA AQD polo.
Oh yeah.
I got like an MVCA polo because I was in the rotational program, so I worked at all the different plants. But
I did. What did I do? I forgot my Eaton gear
yeah.
when I left. I was so focused on making sure I had the cameras, the lights.
Well, you
And-
know, I feel like the suit's professional. That's like the
I
energy
know,
you want
but
to give
I
off.
love to have a tie on here, you know. And
Yeah. Plus,
I
there's enough Eaton in the background that anyone can
Yeah,
figure
look
it
at
out.
I
You're
love
like,
it.
I wonder who's
I wonder
sponsoring.
who he's with. Yeah. You gotta love it. So why don't you let everybody know a little bit about you and who you are and what you do and
Yep.
why you're here.
Yep. So my name is Jeff Schrain. I am the product line application engineer for medium voltage switchgear. I've been with Eaton for almost 6 years. I've been in this role as application engineer for 1 year. Yeah, doing primarily air insulated medium voltage metal clad equipment.
Yep.
But I'm learning everything. We got a lot of products out of the Greenwood, South Carolina plant, so still trying to learn some of the gas insulated, but primarily focused on the air insulated side. And then at this conference, I'm doing a booth on ReliaSense power measurement sensors.
ReliaSense.
ReliaSense.
Whoa. What is ReliaSense?
Yep. So ReliaSense is comprised of 2 products. And these products are not new necessarily, but they're a new application for us. So ReliaSense is Rogaski coils for current sensing,
Okay.
and it is ohmic voltage sensing for voltage sensing. So they're alternatives to traditional CTs and PTs.
Ah, I got you.
Yeah.
Okay. So you're taking the existing technology, replacing it with something else.
Exactly.
What's the value? Why would you do that?
So what I've been explaining at the booth is the 3 things to remember is reliability, safety, and flexibility. That's the 3rd one. So depending on which sensor you're looking at has different benefits.
Right.
For the Rogaski coil current sensor,
Yeah.
I focus mostly on reliability because with that sensor, it doesn't saturate like traditional CTs.
Oh, well, that's big.
A big deal.
Yeah, that's a big deal. So I never knew that. So can you use the same CT for both metering and relaying?
You can. So traditional relaying CT accuracy would be 3%,
Right.
with 10% at 20 times rated fault current.
Yeah.
These Rogaski coil CTs are 0.5% accurate, so they're more accurate than your traditional, and they don't actually have any ratios like traditional CTs would have.
Wow.
So if you're designing like a 1200 to 5 CT, 2000 to 5 CT,
Yeah.
you can just blanket cover them both with Rogaski coils.
Really?
Yep.
Wow. So, okay. So,
That's
Right.
kind of the reliability piece.
yeah.
And another piece of it is also safety. So if you're familiar with CTs, they need to have a shorting
Block.
Yep,
Yeah.
shorting terminal block. So the output of these don't require a shorting terminal block. So there's no shocking risk that you'd have with traditional CTs
Wow.
when you use Rogaski coils.
Wow.
Yep.
Well, that should save room in the equipment too,
Yep.
because you're getting rid of termination points and you're increasing the reliability because you've simplified the installation.
That's right. I wish I had some examples or product demo to show you, but also just in physical footprint space as well.
Yeah.
Smaller, much lighter,
That is pretty.
especially when it comes to hierarchy CTs.
Oh yeah,
Those
yeah,
things are
yeah.
monstrous.
Oh,
They're
my
like
goodness.
This wide and just massive.
Oh yeah, those things can get huge.
Yeah.
And then, like you said, you have the shorting blocks. And I remember my first experience with, I didn't know what a shorting block was. and I had to, I had to watch a couple videos, and I had to, try it, and then I had to go on a job site and short them out. But
Yeah.
I was nervous doing it. Just, you got you're in 4160 equipment, or
Yeah, and they're like, if you do this wrong, you're gonna get shocked. And you're like, okay,
yeah,
I'm doing it right.
I hope I'm doing it right. So, what voltage levels do you typically deal with in equipment?
So medium voltage switchgear is going to be 5 to 38 kV.
Okay.
So these could apply anywhere in that range. So both the Rogaski coil as well as the ohmic voltage sensor.
Gotcha.
Yep. And just to speak a little bit more to the actual voltage sensor piece,
Yeah.
I mentioned the reliability benefits and the flexibility benefits of Rogaski coils. Well, on the ohmic voltage sensing side, the real benefits are safety as well as flexibility. So the safety side is traditional VTs have different failure modes.
Right.
So internal resonance, ferro resonance, switching transients, anything that can degrade the insulation of your VT can eventually lead to a failure. Those same failure modes are not susceptible in ohmic voltage sensing. So it's a safer solution.
Yeah.
And then another big one is flexibility, or really footprint is probably what I should say. Because one, they're a lot smaller. They're picture a surge arrestor. They're mounted very similar to surge arrestors, and they're similar in size, at least in 5 and 15 kV.
Sure.
Well, PT drawers in medium voltage switch, or I should say PTs in medium voltage switchgear, they're going to need a drawer. Well, if your lineup's already filled up, only place to put a drawer is in a new structure.
Yeah.
So everybody cares about footprint, or at least I should say most customers care about footprint.
Yep.
You can actually cut down on your structure count by putting ohmic voltage sensors in the rear of your equipment.
Ah, wow, that's nice.
Yeah. So different customers, if you're safety focused, if you're footprint focused,
Yeah.
different benefits.
Right. So and then you have to translate that into what the benefits are for the customers.
Exactly.
And then hopefully they specify your solution.
Yep. So we have different PowerPoint presentations put together. So I do application engineering for the product line. So
Sure.
I'll do presentations for customers saying like, okay, here's a comparison between traditional VT-CTs and Rogaski coils and ohmic voltage sensors. Here's why you might care.
Yep.
Here are some of the benefits. And we also have brochures and stuff and white papers on the eaton.com/RSM, ReliSense monitoring.
Eaton.com/RSM.
Yes, sir.
Reliable, sensible,
ReliSense.
ReliSense
That's right.
monitoring.
Yeah, because ReliSense is our like portfolio brand name
Yeah.
to cover both of the voltage and the current sensors.
Oh, that's smart. That's smart.
Yep.
That's cool.
Yep.
Cool.
And I think they're gaining more traction. Again, there's nothing new about them, like voltage dividers. That's the first thing you learn when you go to school for electrical engineering. And Rogaski coils are used in a lot of other Eaton products, like low voltage switchgear. The breakers use Rogaski coils. It's just a new application for us. And what we need to see is customers being aware of that option.
Yeah.
So that they can spec it, because it's already in the standards and everything. IEEE C37.20.2, sorry,
Sure.
the metal clad standard, has a full annex on OVS about construction as well as testing.
Yeah.
And then there's a paragraph, I think under some section about current transformers, that basically says you can use Rogaski coils in place of CTs.
Okay.
As long as a customer is aware of it and can get it spec'd, I mean,
Yeah.
we would love to
Do
promote it.
you think eventually it'll just become like a standard part of the product?
I do.
Yeah.
I really do. We're at ESW, a safety conference, right? And safety is just always getting more of a focus, rightfully so. And like OVS is just a safer solution in general.
Yeah.
And then Rogaski coils, the shorting terminal block isn't the main benefit. It's the lack of saturation.
Right.
But I mean, even so, it's still a safety play. And pretty much across the board, you can use OVS or Rogaski coils anywhere where you can use traditional CTs and VTs.
Right.
There are a couple application considerations where you wouldn't want to do it.
Yeah.
But I think it's a great solution that just needs a little bit more traction.
Yeah, you're right. And then once you get people recognizing it and more people specifying it, then eventually it may come to a point where you just say, look, everybody's asking for this.
That's right.
Let's make this a part of the standard product, because now you've switched, because the production lines,
Yep,
right? So you got to
right.
think about production.
Yep.
And
What people are just comfortable with. I mean, switchgear's been around for a long time. In the past 100 years, it's only ever been voltage transformers and current transformers.
that's right.
So changing to something different is just a little bit intimidating, I think.
Yeah,
But it definitely gaining more traction.
that's good. That's a good thing. That's a
Yeah.
good thing. So who do you see buying it? Do you have any specific type of customers that are?
Anyone concerned heavily with footprint. So data center customers are they're always trying to cut down on footprint.
Yeah.
Dynamic voltage sensing can give you that footprint reduction.
Yeah.
Also, data centers. I think one of the papers today they were talking about uptime requirements for
Right.
for data centers. It's like 5 nines, I think they call it.
Yeah, 5.9 reliability.
99.999%.
Yeah.
So anything, if you have a VT failure and it shuts down your gear, you're
Yeah.
going to be a lot more interested in OVS now. So anybody who's concerned about uptime, anyone who's concerned about footprint, would be interested in ReliaSense monitoring.
Excellent.
Yep.
That's good.
If you had issues with saturation during a fault,
That's
coils
I like that because I know we always said that sometimes you have to have two sets of CTs, one for metering, one for relaying or protection because they saturate on the high end.
yep. And then special schemes like high impedance differential
Yeah.
that need high accuracy, like C400 or C200, depending on your ratio. CTs,
Yeah.
it's not really as much of a concern anymore because you're not going to saturate.
That's right. Yeah.
And they're
That's-
just tiny. They're
Yeah,
so small.
they're so
You'll have
small.
to see one in person.
Keep it simple, right?
Yeah.
That's the key. Take stuff out of that equipment, make it compact and simple,
Yep.
easier to work on.
Yep.
A lot of people think compact means less space, but you're giving them actually more space because you're taking components out of that equipment.
Yep.
I like
And
that.
also easier to retrofit.
Oh, I never thought about
Yeah.
retrofit.
You can retrofit them.
How do you install them?
So typically with ohmic voltage sensing, if you're retrofitting an existing PT drawer,
Mhm.
you're just going to put it back in the same PT drawer. So it can be mounted in the rear, but it doesn't have to.
Doesn't have to.
So
yeah.
I mean, the drawer's already there.
Right.
Your rear might be filled with cable. You know, there's physical restrictions maybe preventing you from doing that rear
Yeah.
installation. You would just put it in your drawer. And then Rogaski coils. I mean, typically our CTs are mounted on the bottles of the breaker.
Right.
So if you take your breaker out, you'd see your bottles right there. You could replace them with Rogaski coils.
I like it. I like that a lot. So you got a lot of flexibility.
Yes, sir.
Would love flexibility.
Yeah, pretty cool product, I think.
Yeah. Heck yeah.
As
And you-
people adopt it more.
And you have one over there?
I do, yeah.
Yeah.
Yep.
That's cool.
Yeah. Ohmic voltage sensor, you can picture a surge arrestor. Looks very similar, like with the fins.
Yeah.
That Rogaski coil, just picture a CT, just a lot thinner.
Thinner. Does it have to go around the bus?
Uh,
Still?
It's gonna be around the conductor. In
Oh,
this
okay.
case, it's gonna be the stabs of the breaker.
All right.
So where your
okay.
breaker actually inserts in, we have a epoxy bottle, and
Yeah.
we're gonna mount it right there. And the Rogaski coil itself is actually just like a I don't know what the actual outer material is, but imagine a small silicone ring. That's all it is.
Yeah.
But what we do is we put it in. Oh,
Microphone.
sorry,
Yep.
microphone. What we do is we put it in a housing that resembles a CT.
I gotcha.
So it's going to look exactly like what people are used to using,
I
and
like
it's going to fit exactly the same way our CTs have always fit. It's
Nice.
just going to be more reliable.
I love it. I love it. Reliability is awesome. Simplicity is cool.
Yes, sir.
And make it smaller.
Yep.
But not too small. I had somebody, I was doing a 70E class, and there was a gentleman there who said, you know, if there's anything you can do to take back to your product lines, give us more working space inside of equipment.
Yeah.
And I can sympathize with that,
Yeah.
right? Because they have to get in there, and I always say this, especially when I work on a vehicle,
Yeah.
I always think, I wish the engineer who designed this vehicle would have to change the oil and do the
Yeah.
maintenance, because they would cuss themselves out, because
Yeah.
they would say, why would I put this here?
Yep.
And then they might be able to design a solution. So I'm going to say you need to go out and work on your equipment,
Yes.
because I think that's a really valid part of making sure that we have a product that can be worked on, and
Mhm.
and working space is really critical for a lot of our electrical workers who already have to worry about dexterity with the
Yeah.
gloves
Yep.
and all of that. So
Totally get that.
Yeah.
That's one piece I wish I had more experience with, because my 6 years with Eaton, I've done a lot of engineering of products. I've seen the products at the manufacturing
Yeah.
plant, but I don't always get to see them in the field. And there's a
Yeah.
lot of field considerations, space considerations that you don't even think about because it's not installed, it's not commissioned, it's not online.
That's right.
And then you see pictures from customers and you go, oh, now I see why that's so difficult.
Yeah, absolutely right. I love it. I love it.
Yep.
It's good stuff.
Yeah.
You're the man.
Awesome.
Anything else going on with motors control centers?
I wouldn't say too much else is going on. Outside of Reliasense, we've...
You're next. He's next. That's it. Okay. Reliasense.
Outside of Reliasense, I mean, our gas insulated switchgear, IGX product lines, we're starting to see a lot more of that, seeing a lot more traction with that. Again, footprint. And then kind of back to what you were saying about ease of working space, ease of actually being able to get in there as a user.
Yep.
I will say from the manufacturing side, is like you also hear customers talking about footprint.
Right.
So it's a hard thing to balance sometimes because you're like, well,
I
I want to give a small product.
That's what I always say.
I want to give a product that's accessible.
You're right.
So it's kind of like a tightrope.
That's what I tell all the guys who ask for it. I say, look, we're going to respond to customers' wants and needs, and they want the architect always wins.
Yeah.
So it's a battle.
Yeah.
It's a battle.
Yeah.
One thing. Fight the good fight.
Yeah. One thing unrelated. I heard your second camera. You got over.
Oh my gosh!
Did you get that fixed?
$400 worth of camera. I should get it in the mail tomorrow.
Okay. Nice.
I over voltaged my camera.
How does that work?
You talk on the phone.
Uh-huh.
And start plugging things in and realize there's no internal protection in these cameras.
Oh, no.
When you put 12 volts on an 8 volt, it's
fried it. That sucks.
Yes. And I'm an electrical engineer.
Yeah, well, your setup seems really good.
Well, we try.
Yeah.
We had a rough start, but we got it.
That's awesome.
Thank you, sir.
Yep. Thanks for having me.
Sure thing, brother. Thank you. Good to see you, too. Sergio. Oh, wait, no, Sergio. I need Sergio real quick. I'm sorry. I got it because he's got a booth, right? You have a booth? You got a booth right there. No, I can't pan over. So Sergio Panetta, chair of industry and
industrial and commercial power systems. INCPS.
INCPS. And the big news on INCPS. Well, why don't you give them a little bit of who you are and your background real quick.
Oh, I work for iGuard Corporation. We manufacture high resistance grounding systems, absence of voltage testers, voltage portals, many different products. We're based in Mississauga, Ontario, Canada, and I'm the VP of Engineering. Also the chair of INCPS this year, and with Tom, I'm on the board for IAS.
Yes, we're on the board of directors for IAS, and we had a meeting yesterday. We had a meeting yesterday morning on DC arc flash analysis.
Calculating incident energy for DC arc flash, primarily for data centers.
Yes.
And primarily 800 volts DC for now, because there are apparently many unknowns, but the only thing that we do know for sure is we have to deliver by September. We
have to deliver equations and be able to calculate incident energy. And for these data centers that are going up, that are going to be using DC at 800 volts primarily, that's where they're targeting. So the key thing is we are starting a study group.
Yes.
At INCPS, and the meeting is the first week of May.
First week of May in Lexington, Kentucky. So if you go to your web browser, type in IAS-ICPS, and you'll go to our website. You can register. You can participate. The more people we have, the better outcome we're going to have with the DC arc flash.
That's exactly right.
And all the color books, so the dot standards are being written there, and we can certainly use a lot of help with that. Any knowledgeable people out there,
we need them.
We need them.
We need them.
We need to rewrite these dot standards. The color books are being rewritten into dot standards, and we need more help than we can.
And it's all under your watch, and it's all in INCPS. Those color books I started on when I was in college in I got the 1990 edition I graduated Gannon University in 1990, and I had an internship, and I used the color books. I learned how to do selective coordination.
They're amazing books.
They are absolutely amazing, and now they're putting them into dot standards because there was overlap.
There was
right?
a lot of overlap, yes.
And it makes sense that we're going to start the study group for DC arc flash to develop that method and the equations in INCPS, because there's a 3000 dot series that focuses on power systems analysis.
3002.
3002.
I'm not sure which dot it'll fall under, but it's 3002.
And I tell you, I've been vying for that. So in 3002, you have coordination. That's the old Buff book. You have short circuit studies, voltage drop studies, power quality studies. There's so many reference materials.
It is. And the green book is being rewritten with 3003.
Yep.
The red book is being rewritten. The yellow book, the gold book is being rewritten.
Yes, and now we're going to be in there talking about a study group that's going to develop the PAR for the arc flash. And there's a third party. There's another group that is working on the equations, and and that's what that meeting was about.
Yes.
So that group is we have a technical group that is going to be that is one of my they've met at least 4 or 5 times now. They're going to develop the test protocols, so that we can cause those arc flash events, measure what we need to measure, and then some great engineer, scientist, doctor, and all that other good stuff is going to take that information and develop an equation for us.
Yes.
And the study
daunting.
It's I know, so you're going to have the study group going, and you're going to have the consortium that is making the equations, and they're going to work hand in hand and make sure that we scope out a document that's going to be similar to 1584.
Well, okay.
But different.
The difference between 1584 is when it was being rewritten, we didn't have a model, we didn't have anything, and it only took 18 years to get done.
Oh,
We've got 6 months to do the same.
That's exactly right. We are responding to the demands and the needs of the data center world.
Exactly. They're growing fast. They're building whether they have the answers or not. So we have to get them the answers. We owe them that.
Right. And we owe our electrical workers the ability to dress for success.
Exactly.
And we want to get them out of the 40 cal outfits and plus and get into something that is much more manageable, because we know a lot more about DC than what we can prove on paper, and we just need to get it tested, translated into equations.
Correct.
We're going to do that at INCPS,
yes.
Industrial and Commercial Power Systems. I want to use control. I want to use control and see it's commercial power systems.
Industrial and commercial power systems.
Yes.
That's what it is. It's a division under IAS. And please come by. We need all the help we can get.
Absolutely.
Thank you very much, Tom.
Thank
it was
you.
a pleasure seeing you at
My
ESW.
pleasure.
And you know what? There's a lot of really good products.
Oh,
here,
yes.
too.
And everybody out there has to get iGuard absence of voltage sensors for their equipment. Testers.
Testers.
You rock. I was left hanging.
Sorry.
No.
Come back.
We got it. Boom. Beautiful. Matthew, sorry about that, but I had to get him before he is. Thanks.
Apology accepted.
You are the man, the legend.
I don't know about that, but thank you for having me.
Oh,
Excited to be here.
We had a little rough start this morning. I don't know what I did wrong, but I did something wrong. And we ended up with a new link, and we got everybody out there talking. So we're all up and
I have a
running now.
4-year-old. Every day is a rough day. It's always that way. So
I love it. So how's life with you?
good. Excellent.
Why don't you let
Enjoying the
everybody know who you are?
Should I look directly into the camera?
Well,
or,
I have a B and an A. So
Oh,
that's A.
well, we'll do both. I feel like a newscaster now. So
Yeah.
I'm Matthew Kosnick. I specialize in OT cybersecurity with Eaton. So especially when we think about kind of everything that's going on today at the show, there's a lot of talk about digital, even some of the components around here. And certainly when we're talking about connecting equipment to critical infrastructure systems, one of the things we worry about at Eaton is, okay, well, how do we make sure that those devices and those systems are secure? So that's a big part of why we're here, and that's a big part of why we try to tie it to safety. Because if those devices are compromised, bad stuff
absolutely.
can happen, as they say.
That is exactly where you have bad actors out there all the time looking for opportunities.
Unfortunately, yeah.
Yeah. And we were talking about and I had some, I don't know if it was Steve and a few others that were asking about when we were talking the continuous thermal monitoring and going back to a data system and going to the the web based, and there are a lot of people are like, what about cybersecurity?
Yeah, absolutely. I mean, it's a big part of what we think about at Eaton. I mean, and rightly so for end users, service providers.
Yeah.
I mean, contractors to be thinking about that. I mean, we live in a time right now where unfortunately this exists, and while we don't want to be fear mongers, we certainly want to make sure that the infrastructure and the systems with what we rely on every day, whether it's water, whether it's power, it stays running, and it does exactly what it's supposed to do every day. And digitally connected things, they're great, right? It increases reliability. It can make our systems more productive. But at the same time, if those same devices are being used for other intents, that script can be flipped on us, unfortunately.
Yeah, exactly right. Because like you say, and sometimes a threat can come from the external, but a lot of times the threat is internal.
That's a great point. Unknowingly or knowingly, right?
Oh,
I mean,
absolutely.
think about how often we have third-party maintenance engineers come on site to service our equipment, and they're not malicious people, but they're bringing their laptops on site. They're bringing USB thumb drives with software, with firmware upgrades, and unfortunately, you don't know where those have been. And unless you have a great way to track that, I mean, to your point, it's the insider threat, and you may think you're air gapped, but are you truly?
Yeah. So there were some code requirements that went in the National Electrical Code, and I know some individuals and organizations were not happy with the language because they said that cybersecurity is not a one and done.
This is true.
It's a lifetime adventure of continuously modifying and protecting from new threats that
it's like
that
electrical
rise.
maintenance, right? You're constantly.
Oh yeah. You're absolutely right. Yeah, you gotta constantly stay on top of things.
Yep. And now it's in NFPA 70B now.
Yes.
Where part of the EMP it is exactly that, right? So I think there's some certainly some opportunities to fine tune the language, so to speak. But I think it's getting to the right spot where, to your point, it's a journey. It's not a destination. It's not a one and done. It's, hey, how do we ensure that this equipment not only is installed right the first time, but throughout the life of its existence, people, the operators and the people that really need to know how the equipment works can run it with confidence, knowing that it's secure throughout its life.
Right. And we were just talking about it earlier over in the booth before the event, and we were talking about how you can get an email, and you've got to look at who it was from before you act on it in some cases, especially if they're looking for information or they want you to click on something. And you can have a threat that comes into your system that looks legit. But if you don't ask questions and you're not trained, training is so critical. And sometimes I think just being an Eaton employee, we go through all these different little training things, and I'll spot things just because of the fact that my company has been training me, and it's awareness. And even at home, I share that with my wife. I'll tell Bobby Joe, hey, if you get an email that says from Discover, you didn't pay this or you didn't pay that, or you're going to lose this coverage if you don't do this, you forget about the email and you go to the website, or you make a phone call to that person, the whatever it be, Discover, AT&T, whatever it is. Because there are people out there that want to portray themselves as something else, and then they get into your system, and the next thing you know, like I was a cyber security attacker over here, next thing you know, they bombard your system from inside.
Yep. It's one of what's happening right now is with a threat group called Volt Typhoon, and we try not to attribute to countries. I'll let your viewers kind of do their own research there. But what Volt Typhoon is doing is gaining access to critical infrastructure systems. And then guess what they do after they gain the access?
bombarded or what?
They do nothing.
Oh, they do nothing.
They lay in wait, right? Because
Oh.
I'll get a lot of questions around like, well, Matt, why aren't we seeing anything? That does not mean
They're not
that
in.
that things are not happening. So they get in, they lay dormant, and they're waiting for an opportune moment or saving that access for the
Wow.
right time in which they leverage that access. So it's a great, I think, thing to think about, which is just because we're not seeing things happen does not mean that there are not tremendous opportunities to be hardening our systems, because unfortunately access is being made.
That's a scary thought, and something in the back of my mind is I was just talking to somebody who had something similar where they learned their system. They were gathering information.
Yeah.
For a period of time, and then they knew the operations, they knew and I never thought about learning for the opportune time to make something happen that you don't want to happen.
There's all sorts of interesting techniques. I mean, these are now, I think, when I was growing up, you used to think about cybersecurity as the kid in the basement, trying to hack the government website. These are now sophisticated groups. They have org charts. They have finance departments. They're their own companies. I mean, it's to the point where there are markets where there's like Amazon for cybersecurity or attackers, where they now sell the malware to buyers so that they can then use it. I mean, it's very sophisticated. A lot of these threat groups are highly developed. And to your point, this access they could be using to learn and to educate themselves on how unique systems work. And then, we're not sure what they're gaining the access for. We can only speculate. But certainly, it's a little alarming that
it's not in your best interest.
No, not in our best interest at all.
That's right. That's right. So cybersecurity. So what's going on at Eaton in cybersecurity?
Yeah. So it's really exciting because a lot of the equipment, as I was saying, is now becoming digital, and we're able to bring a lot of great power to customers to assist in their decision making, to help their equipment to be more reliable, to give them visibility into the future from a maintenance perspective so they can be proactive. But with that, at Eaton, we also recognize that we have a what's that quote, with great power comes great responsibility.
Oh yeah.
Spider-Man quote.
Yeah.
We do have a responsibility to make sure that when we are supplying this equipment to customers, that it is coming secure. And when we are servicing it for our customers, whether that's installing it or, like you said, lifecycle maintenance, that we are also ensuring that there is a cybersecurity component to that, so that our customers, can partner with trust with Eaton. And that's a big part of what we do. It's a big part of what we're talking about. The other thing I'll add is, there's a legacy component to all of this. I mean, we know in our industry, these environments are built on a lot of legacy equipment. So it's not only about securing the good stuff that's out there and new today, which we can do. It's also about how do we look back at the stuff that already exists and secure that. So we have capabilities to do that now, where we can come back and help you extend the life of that equipment by ensuring that it stays secure.
That makes a lot of sense. Now, do we offer a service, or will we go out and work with customers?
Yeah. So we'll do a little bit of both. We try to be that puzzle piece that fits in for the customer. And so, especially in our world, electrical power management, cybersecurity is pretty rare. There are others that will do cybersecurity, but we love to partner with customers in that specific space to help them where they are. And if they need services, boots on the ground for installation or installation or life cycle services, we want to be able to offer that for them. So that's a lot of what we do.
Yeah, and we evaluate. So any of our products that communicate, do they have to go through your team?
They do, yeah, absolutely. I mean, our cybersecurity team is big. We're the service group. We have a whole other group that does secure by design. I mean, one of these days we should take them to the labs that we have there, the cybersecurity labs.
We can do that.
That are IEEE certified labs. They're phenomenal, actually. Where we do all the testing.
Where is it in Cherrington?
Yes,
it's in Cherrington. So I do at the end of May, I do a Shock Week.
Yeah.
And Shock Week May is Electrical Safety Month.
Yeah.
And so I record videos.
You should do it in the lab. It's phenomenal.
Well, we can go in. I can bring. All of this stuff is mine, so I could come down and we can sit and you could talk about it, and we'll record it and then we'll air it during Shock Week.
picture speaks 1,000 words, in my opinion. We can talk all we want, but your viewers probably want to see, okay, well, what does this really mean?
No, that is exactly freaking right. That's perfect. Wow.
There you go. The plot for the next episode.
Yeah, I got a plot for Shock Week 2026 is growing by leaps and bounds. That's just good stuff.
Awesome.
Yeah, you gotta love it. You gotta love it. And people in the booth, are they hacking over there?
Oh, hacking away, yeah. But I mean, for your viewers, it's a bummer you're not here, but we have a simulated cyber attack to kind of show what it can look like if you don't have protected equipment, right? And then we do the, you know, the old egg commercial, your brain on drugs and not on drugs, and we show you how to prevent that attack by making sure the equipment's in with some Eaton gear.
Now, now is our cybersecurity product, is it like you buy this and install it, or is it built into all of our solutions?
Yeah, so most of the devices that we sell, it's built in. So a lot of the capabilities, you know, being able to do network throttling and things like that. I mean, we're building into the gear, the new stuff. But going back to the legacy point, you know, we still need to make sure there's equipment to help customers that, you know, might be running gear that just, you know, wasn't designed with cybersecurity in mind. And, you know, we're 10 years down the road and now, you know, all new kinds of threat and new kinds of ways that we're being attacked and being able to help customers there with products. So we do have products that we can, you know, help either supply with the old gear as part of retrofits, or we could come in and help customers after an assessment.
Sort of a speed bump or a barrier to those external people.
It's exactly right.
I like it. I like it.
Awesome.
We're from Eaton and we're here to help.
Hey, that's absolutely right.
I love it.
Well, we're getting the hook, I think.
Yeah, I think you're getting the hook.
Tom, thank you so much.
Thank you, sir. Be good, Matthew. Enjoy the show. Try the veal. I'm here all week. Well, no, not veal. I mean, a lot of people don't like veal. Oh, Eric Campbell, the man, the legend, the next chair.
Next chair. How you doing?
I'm doing good. You gotta hold this up here like this because it is pretty noisy.
And look at the camera. Look at you. Look at the camera.
Yeah, give him a good smile. So tell us who Eric Campbell is.
So Eric Campbell is an electrical engineer that lives up in Seattle. I started my career essentially in the Navy. I was a gas turbine system electrician, power plant operator on a fast frigate.
Oh, wow.
Thought I wanted to go into nuclear engineering.
Yeah.
So I eventually transferred to ASU to join the nuclear engineering program. Changed my mind. Thought I'd work at a normal power plant. Changed my mind as working as an electrician in college, and thought I want to be a consultant. I want to stamp drawings.
Awesome.
So.
Excellent.
That's the history of me, and now I work for Brown Caldwell Engineering. I'm the director of design practices. I work with our national practice leaders to develop standards and procedures for construction documents.
Wow, got a big responsibility there. Yeah, stamping drawings?
I do. I have many hats there. I stamp drawings. I work on the cool but big electrical projects.
Sure.
I'm our only fire alarm SME. And I'm also our electrical safety officer.
Electrical safety, and that's what brings you. Thank you very much. That's what brings you to the electrical safety workshop, and you have been coming for I can remember you since I've been coming.
18 years, I think.
18 years.
18 years.
That's awesome.
And I had ulterior motives when I came.
Oh, you did?
I did.
What were your ulterior motives?
So we were going after a lot of arcflash work, and the proposals say we wanted arcflash. You know, we want, arcflash labels per IEEE 1584. And I discovered 1584 meets at this conference.
Yeah.
And I was like, wouldn't that look good if we're going after projects? And on my resume, I can say I'm a 1584 committee member.
Sure.
And I stayed for the conference and went back to my company and I said, we need an electrical safety officer because of this. And, here's the type of person I think you should get. And they kind of walked out and walked back and said, okay, that's what we want you to do.
Wow, that's pretty cool. Created your own position.
Created my own position.
That is awesome. That's awesome. So you have been involved with the organizing committee.
Mm-hmm.
And for a while now, and now you're going to be chair next year
Chair
of
next
the
year.
electrical safety workshop, and we're going to be in Reno.
We're going to be in Reno, Peppermill Resort.
Yeah,
It's going to be a great location to bring companions. Going to have a lot of activities for the companions, whether or not it's with the spa or
yeah.
planned walks for steps, group walks, and all different types of things. It's going to be fun for all.
Yeah, we had a really good turnout here, and we just keep growing. So next year, you're going to break another record, aren't you?
I hope so. I hope so. This year we've had over 600 people, and a third of them first-time attendees.
That's amazing. I think that's the record this year. Is the first time attendees just through the roof.
That's my understanding as well.
Yeah, and the team works so well together. Everybody knows their role, and we all do something. I put the book together, and what's your role on the board, on the group now?
So, incoming chair, and then chair. So I was the construction subcommittee chair.
That's right.
And I had to step away from that just because of prepping for all of this. And I'll be the outgoing chair the year after, and then I'll see how best I can contribute.
You'll be a has-been.
I'll see how best I can contribute. There's a lot of parts and pieces in the committee. That is why ESW is so successful, because there's so many people with passion and particular roles, and they all work together, and it all comes together in this symbiotic, great conference.
Absolutely right. There's so many solutions. I had Lanny Floyd earlier, and he started back when he said there were like maybe 18 or 30 people or whatever it was at the first ESW, and we've come a long way. But it's to your point, it's like-minded people,
exactly,
who care about safety. And it may be that you have a product that you want to sell into the world of safety. It could be that you're an electrical worker who just wants to learn what are the solutions and how do I work safely. There's so many reasons to be involved with the group, and so many opportunities to get involved.
And not only that, but I see like all the senior people that we have here, they don't necessarily, they have so much to give and so much to say.
Yeah.
But they're such great listeners. And it's that listening that just pulls the young people in, the first time people, and makes this homogenous, helps get over the apprehension of being in a room with you feeling like you're in a room with a bunch of smart people and you don't know anything.
Yeah.
They just make you feel comfortable, and slowly, after a couple of ESWs, you're in that same role.
Yeah, you're right, because we're all mentors. And there's a lot of, most of the people that you meet here realize they don't know it all, and they love to hear your message. Some people think they know it all.
There's one or two. We might have a gong. We might have it, for those of you that remember the Gong Show, we might have a gong up on stage in Reno, just lighten things up.
I know. Boy, well, that would be perfect. I can see it. A gong on, and what was his name who did the Gong Show? Remember, he used to go out and dance. I can't remember his name.
I can't remember
either.
but
that would be cool. But there's a lot of really good, a lot of knowledge, a lot of great people building a Rolodex of all the individuals who either serve your market or have something to share. And
absolutely,
when you have questions, we'll answer the phone, right?
Absolutely.
Yeah,
absolutely. There's been many people. My Rolodex, whether or not it's Lanny Floyd or, and I'm going to mess up the names, but there's just so many people.
Oh yeah,
so many people.
So far, what do you think your best, your favorite paper that you've heard so far?
That's a tough. Put me on the spot. They've all been.
It's what I do.
They've all.
They're all good.
They're all good, and it's been eclectic, I think, this time. There's been a really good mix of presentations, both technical and real world, and Lanny's today about personal stories. And it's and honestly, it's unfortunate that so many people have personal stories.
Yeah, oh yeah.
To
To share. Yeah, we all have that. And yeah, you're right. It is either directly or people they knew, and everybody has something. If you're, it doesn't have to be in the electrical world, right? It could be anybody, and people you know got hurt from electricity, and it is what it is. But it's a shame. So you've given papers here.
I've given a couple papers. Let me backtrack real quick. So I thought about it and it clicked in mind. And it's funny when we talk about how eclectic this is.
Yeah.
So there's a PhD professor that's a lawyer that gave a paper on 4 different types of burns. And that was just nerdy, but it was riveting. Like really understand and not even think about that from an aspect and the things that can tell you.
Oh, absolutely. You know, the more, like when I have a 7E class I give, and we talk about burns and how the skin, the different layers of skin, and then the eyes and your ears, you know, trying to relate it to sound and all the large sound that an arc flash will make and the impact on your hearing and whatnot. The more you know about all the different pieces of the puzzle, it's just the more you realize you want to wear your PPE.
Exactly.
It is so critical. But yeah, so I'm looking forward to you as a chair. Oh my gosh, I can't believe it's like he's gonna be chair. We're gonna have a blast in Reno.
Yes, I was really apprehensive coming into this and the responsibility, but as we sat there and it was being presented, I can do this. I can do this. We'll have
a great
fun.
Team.
Yes, we have a phenomenal team.
Yeah, that's the biggest thing. When I chaired it a few years ago, it is scary, but then you realize, you've got I call it like a fine-oiled machine. They've done this so many times. They know exactly everybody has a role, and we argue, and we'll complain about this little detail or that little detail, and because you're fine-tuning, and the team is gelled over the years, and we get it done.
Well, there's a handbook to follow, and it's really informative, but it's also it's like a safety program. The handbook is dynamic.
Yeah.
Right? It's not static. So each year, the chair brings back their experiences and trials and tribulations and contributes to making that handbook just a little bit more comprehensive and
exactly.
And assisting, again from that family perspective, just assisting the next chair coming in.
Yeah, absolutely. There's so much everybody works together. It's like a big family.
Yes.
It really is like a big family.
It really is.
And there's a lot of opportunity for more people to be a part of the family.
Absolutely. Come out to ESW.
Absolutely. Come out to the ESW next year. You get to see him on stage with a gong.
Come to Reno.
Come to Reno.
Bring a companion.
Pepper Mill
Resort. All rooms are a suite. All rooms have a jacuzzi tub. Great restaurants.
Yeah.
Very adult theme.
Spa. Yeah. And it's at the end of March this year.
It's at the end of March. It starts on the 22nd to the 26th.
Right before my birthday, which is the 29th.
And my birthday's on the 20th.
Oh, really? March?
Yes.
You're an Aries?
Yes. No, I'm a Pisces.
You're a Pisces. Oh, why do I even have you?
I'm a Pisces Aries.
You're a Pisces.
You're
on the edge.
Right on the edge. Yep.
Yeah. Always. That is you. You live on the edge.
Absolutely.
Absolutely. And we love to have fun. So that's the other thing. Work hard, party hard.
Absolutely.
Yeah.
Absolutely.
We work hard during the day. We learn from each other. We got papers going on. When we're doing the event, there's a lot of parts and pieces moving. And then afterwards, we enjoy each other's company, share a beverage or two, or three.
Or
yes, good food. Oh, yeah. I tell you what, I told my wife I was going to leave here a few pounds lighter. Ain't going to happen.
No.
I should never have made that promise, but but it is what it is. So, but yes, I'm looking forward to next year.
So am I. Looking forward to all of you coming out as well.
Meet us at the Pepper Mill.
Pepper Mill. Bar in the round, right in the lobby.
right in the Robbie.
Right.
I love it. Thank you, Eric.
Absolutely.
You are the man. Appreciate it. All right, we are getting close to the end. We had Derek. We were live. We were doing good. Is it live? It is. Howdy. Eaton makes ohmic sensing for medium voltage T-bodies. I'm not sure what a T-body is, but yes, we do. We make medium voltage sensors. Come on. Go to channel, pin, message, remove, add as moderator. What the heck? I got a chat. I got the live chat. There we go. There we go. So we got Derek from Shock Week. Yes, he is there. Steve. Robert, pressure terminations are almost always the first to be damaged by heat because of thermal expansion. I would agree with that, Steve. Tammy Gammon, what is the product name for bus duct sensing? Bus duct sensing, it's still continuous thermal monitoring, and we do the bus duct. We have continuous thermal monitoring in bus ducts, and we've got Mike.
Ubanovsky.
Thank you. I was going to go Ubban, but I'm sitting there like, no, it's Ubanovsky.
Good to see you.
It's always good to see you, sir.
So
low voltage power, low voltage breakers? No.
No. I want to talk to you about the NEC.
Oh,
that's right.
That's right.
So I have no products for you right now.
Okay.
So
Okay.
I wanted to talk the NEC and talk about the new formatting that's coming up here in the
whole reorganization.
Yes.
There is.
So I guess let me tee this up a little bit for you. So, the code has been the same 9 chapters forever. I looked back on my shelf the other day and I had a 1993 code book and it was still the same 9 chapters. And then I read somewhere, probably on one of your slides.
Yeah, maybe. Keep it close. Keep it close.
That the code has been that same format since 1923, I think you said.
Yeah.
So that's a long time. People
time.
get really used to the format. If you're whether you're out in the field or a consultant designing projects, you know where these tables are, you know where these different chapters are, and you've got them all flagged. Everybody's code book is filled with little sticky notes all over it, right?
Absolutely, yep.
So now to go from 9 chapters to 30, I believe, right?
Yeah, there's going to be a bunch of chapters.
So I guess my question to you was, of course we've got technological changes over time, over that period of time, vast array of different advances in technology. So certainly incorporating in, we didn't have EV chargers or any of that stuff. We didn't have as much DC, control power and DC circuitry back then. So certainly there's a need for it. But I guess what's kind of the code making panel's driver behind the reformatting and so many chapters, and now everybody's going to be kind of thrown for a little bit of a loop for a while.
There's anytime we're all adverse to change. I mean, everybody loves to have consistency. We're like dogs, right? my dog loves consistency. I'm the same way. But to your point, technology has changed over the years, and there is an individual in Alabama, Donnie Cook, mentor of mine. He's good at asking questions. And what he would do is he would look at the NEC and look at a chapter, and he would say, help me understand how this is special equipment, right?
Right.
And we would look at it and say, well, swimming pools, right? You'd say, well, swimming pools, is this special equipment? Well, not really. I mean, it's not special equipment. I mean, you've got GFCIs out there, you've got, grounding and bonding, and it's not special equipment, you know? Is it in what he calls it, is it in the right bucket? Because one of the biggest challenges that we have in applying the code is when you look at something, say I look at lights and I say, where in the National Electrical Code would I go for the rules on lights? Right? So you'd say, well, the way the thought processes go, well, is it standard equipment? Do I go to chapter 4? Do I go to chapter 5, chapter 6?
Right.
So the code is laid out, and there's an education, there's a book that I think it's IBEW put together that's called Codology, and it helps you navigate the code. But when you start to try to navigate the code, you ask those questions: is why am I going to this chapter for that when I think it should be somewhere else, or maybe the bucket doesn't exist?
Yeah.
And so Donnie kept asking the questions.
So you're saying that what Donnie was bringing up is that the way the code was organized wasn't as intuitive as it could be.
Right. And it could be that over the years, we've introduced so many new technologies that it's causing people to say, is this the right category? Is this the right bucket? So they had Larry Ayr as the correlating committee chair. He pulled together a team, and I remember the first meeting that we had was out in Philadelphia, and they had to pose the question, and we looked at photovoltaics. We looked at medium voltage, because medium voltage is dispersed throughout the code, and somebody would say, well, why don't we have a chapter on medium voltage? Well, if you're going to have a chapter on medium voltage, you already got 9, so is it going to be chapter 10, right? And if you have a chapter 10, then 90.3, which tells you how the code's laid out, is no longer, how do you handle 90.3? Yeah. So we started down that road, and somebody said, well, what about photovoltaics? Should we have, like in hazardous locations, you have chapter 5, 500, 501, 502, 503. 500 is like the general requirements.
Right.
So somebody said, well, should we have a chapter in chapter 6? Should we have a 690, 691, 692? And 690 has all of the general requirements for anything that is inverter based, where I'm taking DC and going to AC because I have an inverter.
Right.
Well, an inverter that I use on a PV system, what's the difference between that inverter and an inverter on a battery system? Should we have the general requirements? So how that I call it the snowball, or a drive, exactly. Yeah. So you sit down and say, well, how you ask those questions, and then that team started to realize maybe this is a little bit bigger than just moving a couple articles around. So then they expanded the team, and now they're getting to a point where their goal is usability. They want to make it so that you can easily find what you need to make sure that you're installing the solutions correctly. Now, the question is, are these changes going to get us there? And nobody really, I've spoken to people on both sides. I'm relatively neutral.
Right.
My concern is all of our literature that references sections. How am I going to reference these new sections? I'm a part of NEMA. We have the same concern because we have a lot of NEMA documents. I'm very neutral in this concept of, is it going to help me or hurt me? I just learned the code, and I'm still learning the code. Now you're going to change all expand all the chapters. I don't know that it's going to help me, but I'm going to continue my learning process.
I guess if they approach it in a very systematic, organized way that makes sense, the question is, who are you asking? Does it make sense to?
Exactly.
You know,
is it the inspector, the electrician?
Yeah. Are you going to IBEW, meetings and go, does this make sense to you? Does this flow make sense?
So that's what we did. So we went to, and we put it out there for everybody, but on that committee is an IBEW representative, a NECO representative. Larry Ayr is with the independent electrical contractors. Yeah. And he's the chair of the correlating committee. We have electrical inspectors, and I'm a student, right? So we've presented at all these different IEI chapters, and because it's a part of the IEI presentation, and we're helping people be educated and aware of the changes that are coming. Yep. And we're saying, is this going to help you? And what I'm seeing are inspectors and electricians all saying this is going to help. So I have high hopes, right?
Yeah.
I can't say whether it's going to help me because you know as well as I do.
I'm sure you're going to have a lot of people out there who have been doing this a long time and used to the current format.
Oh yeah.
They're gonna not be very happy.
Yes.
With this, but
it is. I said what I always say whenever we make changes. I say, just when you thought you knew it, we decided to shift it up a little bit because we wouldn't want you to know it all that well.
Right.
But it's a It's a challenge. It's going to be a challenge. It's an opportunity for people who educate, for organizations to take a leadership role.
Yeah.
Right? So I looked at NEMA as one of those and said, let's lead. Let's be one of those organizations that says we will help you understand this new architecture and do that in a systematic, methodical, educational way to give people the materials. I think, and NFPA Link. I don't know if a lot of people who watch my channel and whatnot they all have NFPA Link, and a lot of this reorganization is going to help the search engines and the AI agents.
That'll be good.
Oh yeah, if you talk to some of the leaders back at NFPA, they're saying, "Look, Tom, we're going to take and we're going to make the code. You're going to hopefully be able to say, I have a lighting fixture. It's 120 volts, or if it's 240 volts, it's 30 feet in the air. It's hanging from a cord. What code sections do I need to reference to look at to make sure that the installation is adequate?" I mean, AI is growing so fast. I don't know that that's not achievable.
Oh, I very much think it's achievable. I think if you asked AI that today, it would give you some pretty good accurate feedback.
Yeah.
Even today.
Yeah.
So,
but you always got to question it.
You do.
Yeah.
Trust but verify, right?
Yeah, trust but verify, absolutely. Until it gets refined and perfected, at some point in the future, we may say, look, this is solid. It's a trained, model, so to speak.
Yeah.
But
definitely.
But yeah, I would say the new technologies drove it. Usability drove it. The fact that we have got so many things in, I think, probably the wrong bucket is driving it, and we're just trying to get things to be more usable, more user-friendly, and that drives accuracy and implementation of the code. So
absolutely, I agree.
That's my story, and I'm sticking to it.
Sounds good to me.
I love it. I love it. But yeah, and then some of the big changes. Medium voltage is big, but another really strategic one is the low voltage power. Remember Chapter 8?
Yep.
Chapter 8 always was independent, and it said it was separate from the rest of the code. Well, they're realizing through Class 4 power, which is pulsed DC at like 400 volts or 300 some volts. The concern is safety, but do we have the right conductors? We're putting more power over small conductors.
Right.
And somebody's asking the question, should we be looking at those installations? Why doesn't chapters 1 through 4 apply to these applications? Right? So they've removed in the 2026 edition the independence of Chapter 8. They moved
sprinkled amongst the rest of it now.
Yes, moved it into Chapter 7, Chapter 3. If it's a wire, it's going to have to follow the rules of wiring methods and materials, and they want to protect the conductors. So that, and they changed 90.3. So they changed the I'd say the enforceability of the code in those applications. And we're getting to a point where the technology's taken off where it's a safety concern.
Yeah.
And even the people that make those products, they embrace it, because the last thing you want to do is introduce a new technology, which like the pulsed power was I think Volt Server was the one who brought it to market.
Mm-hmm.
They introduced the technology, it was awesome. They were using it. They didn't have code sections and code requirements around it. They were applying Chapter 8. Okay. But then even those who are interested in that technology are saying, look, we need rules and regulations around this because we don't want to burn a facility down. We don't want to hurt anybody.
Right.
So let's bring that into the balance of the book and make something that
protect everybody.
Yes.
Yep.
And then that'll protect the technology.
Mm-hmm.
So I think it's all good stuff. I think it's all good stuff.
Very good.
Yeah. You enjoying the show?
Very much so. Very good interaction with customers.
Yeah.
Talking technology. It's been a great show. Happy to be here, and my feet are hurting.
Oh, I'm telling you, I'm looking forward. You guys got to eat. I didn't get to eat. I didn't have breakfast. I didn't have lunch. I'm waiting for I'm thinking that steakhouse that's just down the road or down the.
Yeah, I
This-
think there's one in the facility here.
There is, and what's nice about this facility is it's got a water park, so a lot of people brought their kids, and that's the cool thing about the electrical safety workshop. Like next year is going to be the pepper mill. Eric was talking about that. You can bring your family, and it's almost like a vacation, and
Oh, absolutely.
have some fun.
Yeah, I know coworkers here today that have brought their families along for the ride. So
Yeah.
So I guess we can expect to see you going down a water slide in your bathing suit with a steak in your mouth.
That would be a good picture. I'll get a selfie. I think not.
No.
Okay. Yeah, I didn't bring my bathing suit, so Tom, you won't see Tommy D in a Speedo going down the slide. Ain't gonna happen. Yep. Everybody would lose their meals.
Right.
Right. Look at him. But yeah, no, I'm glad we have a great turnout here. A lot of equipment, and it is.
Yes, sir.
It's 6 minutes after 6. We've been going 3 hours straight. Robert from Omaha, thank you for joining in. We had some good dialogue. We had a rough start. Somehow, I'm gonna blame it on cybersecurity. I think I deleted the feed by mistake.
Uh-oh.
Yeah. Nihad was saying, boy, you didn't stream to Facebook, so I wanted to go in and make sure that I didn't have a problem. So I removed what I thought was just Facebook, but I think I took
everything out?
I think I did. So
user error.
It was, and I'm sure I'll get yelled at, but it happens. All right, everybody. Thank you for being here.
Thank you, Tom.
You're the man, the legend.
You're the man. See you guys.
We'll see everybody at a YouTube channel near you. All right, I'm going to sign off. Take care. Thanks for joining in at the Electrical Safety Workshop. You'll be able to watch this 24/7, 365. Go over it over and over and over. And I will look and make sure I do a session to answer any questions I was not able to get to. It was kind of hard to get it all done at the same time. So I will hold a session that looks at all the questions and answers them. And I look forward to seeing everybody at Shock Week at the end of May. And maybe you might see this guy there too. You never know. All right. Take care, everybody. Stay safe, and please stay healthy. See ya.
See y'all.